He drifts toward a horizon that is not a line but a thinning of certainty, a place where star counts falter and the illumination of home loosens its grip. The disk behind him is a slow-turning lantern, a braided river of light wrapped in dust and memory. Ahead, the sky grows grainy, like frost on old glass. Here the Milky Way becomes whisper rather than proclamation, a hush where bright waypoints surrender to sparse embers and the geometry of belonging begins to blur. Silence thickens. Even the cosmic background seems to lower its voice. The traveler feels a tide of darkness rising, not hostile, only wider than his language, older than any chart he carries. He watches the last confident constellations break apart across perspective, a reminder that patterns are stories drawn by proximity. With distance, the architectures of childhood drift into ambiguity. Stars that once aligned as a mythical archer now scatter into unrelated neighbors. The myth evaporates, but something else appears in its wake. In the widening gaps, an order of a different magnitude begins to show itself. Grains hint at a faint lattice. Velocities imply a choreography. The whole becomes viewable only when the familiar fractures and the mind learns to see through the fractures into a subtler unity. The tide of darkness is not empty. It carries dust so cold that it refuses to shine, gas so diffuse that a cubic meter would be poorer than any vacuum dreamed by laboratory glass. It carries snowmelt remnants of ancient supernovae, metals diluted to whispers, ions drifting at temperatures that seem paradoxical to their thinness. Every cubic light-year holds a ledger of past violence turned into future fertility. Somewhere behind him, in the disk's crowded neighborhoods, these ledgers will one day be withdrawn as new stars. But out here the account accrues interest slowly, almost shyly, over spans that challenge verbs like become and change. The traveler senses gravity less as a pull than as a field of allegiance. The galaxy's center no longer commands, it negotiates. The grip eases into a handshake across uncounted orbits. Escape velocity becomes a story told in conditional tense. If momentum carries, if tides cooperate, if the small engines do not tire, then the edge might be crossed. Yet he is not certain that edge is the right word. What he approaches feels like weather around a mountain rather than a wall around a city. The mountain remains, unarguable and massive, but the weather is its living extension, its breath moving across larger territory than any map of stone could claim. Starlight thins. In the thinning, he hears chronology change key. Within the disk, time is measured by the lives of suns. Out here, time stretches to the lives of orbits that no star owns. A comet does not hurry in such a regime. A star stream carries the memory of a collision that no one alive remembers. The past is not behind, but around, folded through space as a shawl of trajectories. He thinks of how the Milky Way glows not because it is singular, but because it is crowded. He realizes that crowdedness is a kind of shelter, an atmosphere of companionship. Leaving it is a step into an honesty that can feel like bereavement. He sees clouds that do not look like clouds. They reveal themselves only by what they do to light passing through them. Background galaxies wear faint bite marks in their spectra. The bite marks line up across the sky like a code. Temperature, density, composition. Together they sketch a figure that cannot be drawn with ordinary ink. The figure looks like a halo that is both substance and story, built from outflows that cooled, inflows that warmed, and ancient feasts where the galaxy ate smaller neighbors. The taste of those feasts lingers in the chemistry of the airless night. Calcium from shattered shells, oxygen from detonated cores, carbon from the slow patience of dying red giants. The traveler cannot inhale any of it, yet the mind breathes it in all the same. The edge glows in paradox. Less light, more meaning, fewer stars, deep emotion. He passes a solitary blue star whose velocity is ill-mannered by local standards. It barrels along as if flung from a sling. He tries to feel the story hidden in its speed. Perhaps at the center, near a black sun that keeps its own counsel, gravity once braided too tightly and the braid snapped. Perhaps a binary was unstitched by a dark companion, and this survivor was sent outward like a seed on a high wind. It does not matter which detail is correct, so much as that the details point to a larger habit of the galaxy. It keeps its shape by letting pieces go. Ahead, darkness seems to acquire texture. Not the texture of dust lanes threaded through spiral arms, but a velvety, statistical granularity. He recognizes it as the signature of something that does not shine. It behaves like scaffolding rather than sculpture. It does not seek applause. It anchors what does. He cannot touch it, but the way stars orbit tells him where it sits and how far its influence reaches. He realizes that this influence extends well beyond the last visible stars. What looks from the inner suburbs like emptiness is in fact a long tail of belonging, a place where the Milky Way's identity thins but refuses to vanish. The Voyager catalogues the shift in color as he moves outward. Warm golds and cool whites give way to punctures of blue, and then to a dominion of faint reds and barely there embers. The human eye is poor at such low light levels. Instruments translate for it, turning deprivation into data into a kind of second sight. In this second sight, the galaxy appears as a layered organism: core, bar, spiral, thick disk, thin disk, halo. Yet none of these layers end abruptly. They grade into each other like winter into spring, and then spring into that long afternoon when one cannot say whether it is still spring or has already become summer. Listening becomes more important than seeing. The Voyager listens to pulsars ticking in remote enclaves, each tick slowed by gravity's curvature, and by the way, motion stretches time like taffy across the void. He listens to the hiss of charged particles rushing along magnetic fields that faintly skein the halo. He even listens to silence, discovering that it is not empty either. Silence contains forecasts. In the quiet, trajectories announce intentions. The galaxy intends to hold on and to let go, to circulate and to exchange, to be a home and a crossroads. Here, the edge offers an education in humility. The traveler notices how easily language invites the wrong metaphor: border, frontier, outside. Each word implies a discontinuity that nature declines to provide. The closer he looks, the more the edge behaves like a gradient that has been misread as a line, simply because minds prefer lines. Lines are easy to draw and easier to remember. Gradients ask for attention over time. The traveler pays and is rewarded. In the gradient, he finds a new pace for thought, one that matches orbital periods rather than human schedules. He pauses where a handful of ancient globular clusters keep company like elder islands. Their stars are old enough to remember a different metallic alphabet. They carry a shortage of heavy elements, a hint that they were born when the cosmic cauldron had not yet learned to cook elaborate recipes. They circle the galaxy at canted angles, unbothered by the equatorial politeness of the disk. Their orbits are long, their conversations longer. If the disk tells the story of the present, these clusters recount prologues. The traveler does not interrupt. He lets the silence between their sparse suns explain the patience required to understand a system as large as a galaxy. Past them, the sky grows sparse enough that motion stands out. Trajectories write themselves in crisp handwriting across spans he can finally read. Thin rivers of stars pull faint diagonals through the dark, remnants of smaller galaxies that wandered too close. Each river is an obituary and a birth announcement. The galaxy lost a neighbor. The halo gained a scar that will heal into structure. The traveler notices that the further he goes, the more the Milky Way seems less like a single object and more like a continuing event, a verb that is still conjugating itself through time. The light behind him diminishes to a shawl rather than a face. Ahead, the universe waits without hurry. The traveler understands that crossing a boundary is not always a movement from one thing to another, but a deepening into the nature of relation. He is not leaving the Milky Way so much as entering the condition that allows it to be. The faint edge is not an ending. It is where the galaxy converses most frankly with its environment, where the exchange of matter and momentum writes the first sentences of any future star. He leans forward and lets the gradient carry him a little further. They begin with a question that sounds simple. Where does a galaxy end? The earliest cartographers look up from small domes and chilled eyepieces, taking attendance of star clusters that refuse to sit inside the orderly plane. Harlow Shapley traces the distribution of globular clusters and realizes that their congregation outlines a spheroid around a center far from the Sunday. The map reveals a swelling around the luminous disk, a pale architecture that does not care for spiral etiquette. In that geometry, he sees the first sketch of a halo, a population older, poorer in heavy elements, and spread like a faint shell around the bright wheel. Others add strokes to the emerging contour. Jan Ort notes hard-running stars whose paths ignore the traffic rules of the disk, a sign that a larger gravitational context is at play. Photographic plates grow into surveys, and surveys into catalogues. The halo stops being a rumor and becomes a ledger of objects that move on orbits askew to the familiar plane. In the mid-century, radio astronomers eavesdrop on neutral hydrogen, mapping clouds that drift at implausible speeds. Their velocities hint at reservoirs of gas beyond the disk's tidy lanes, a hint that the atmosphere of the galaxy is not the thin skin once imagined. Cartography matures when light is not only gathered, but dissected. Quasars serve as backlights, their spectra pierced by absorption features that do not belong to the distant beacon, but to the material in front of it. Astronomers notice fingerprints of magnesium, carbon, silicon, oxygen. Each line marks a parcel of gas that sits between the observer and the distant lighthouse. Piece by piece, a circumgalactic medium comes into view. It is not a cloud. It is an environment, diffuse and hot, sprawling far beyond the starry suburbs. The halo acquires breath, an exhale and inhale of matter trading between disk and space. The photographic era yields to digital sky cartography. Detectors count photons like patient accountants. The Sloan Digital Sky Survey unrolls a map that is both census and revelation. Star counts begin to show rivers that do not belong to the spiral arms. Tidal streams are traced across constellations, the fading remains of dwarfs that wandered close and were gently pulled apart. What seemed a clean boundary becomes a lace of memory. In 1994, a small galaxy is found insinuating through the southern sky, its stars looping in a polar ring. The Sagittarius dwarf spheroidal becomes a teacher, demonstrating how encounters paint long signatures into the outskirts. Space telescopes sharpen the quasi-linear scratches into proper handwriting. The Hubble Space Telescope teases out narrow filaments like GD1 and the sinuous tails of Palomar 5. Each stream is a ruler laid along the halo, measuring gravity with the spells of motion and dispersion. Spectroscopy attaches ages and metallicities to the streams, converting the map into a history book. The stars tell of places they were born and epochs they crossed. The halo, once imagined as a smooth envelope, shows itself as a palimpsest of feasts, each course leaving a faint aftertaste in chemistry and kinematics. The act of mapping expands to include heat that eyes cannot see. Chandra and XMM Newton sense oxygen ions that only exist in million-degree gas. Their signatures drape across the sky, weak but persistent, implying a volume of hot plasma that dwarfs the visible disk. The circumgalactic medium is not merely present. It is capacious, holding as much or more baryonic matter as the galaxy's stars. The numbers surprise. Missing matter that failed to appear in earlier tallies finds a plausible residence in this hot reservoir. The map is forced to become three-dimensional, with temperature as contour and pressure as shading. In the ultraviolet, the cosmic origins spectrograph turns background quasars into needles that sew through the halo's invisible cloth. The COS Halos program measures metal content and ionization states around galaxies akin to the Milky Way. The data show that halos are chemically mixed and dynamically alive. Outflows from star formation and black hole tantrums enrich the gas. Inflows from the intergalactic medium replenish the disk. The old intuition of a wall gives way to a model of circulation. Cartographers change their tools. Boundaries are no longer lines on a flat chart. They are gradients of column density, gradients of entropy, gradients of memory. The Gaia era arrives like sunrise. Suddenly the positions and proper motions of more than 1 billion stars are known with exquisite precision. The halo stops being a haze and becomes a choreography. Substructures leap out in velocity space, revealing mergers with names that sound like legends. A long-ago collision nicknamed Enceladus, or the Sausage, spills its signature across the inner halo, a crowd of stars on elongated orbits, chemically distinct and dynamically coherent. Another remnant, called Sequoia, contributes a smaller population on retrograde paths. Each discovery adds a chapter to the atlas, a reminder that the outskirts are a museum of ancestral encounters. Ground-based surveys keep pace, each new instrument widening the census. Pan-STARRS uncovers more shells and arcs. The Dark Energy Survey outlines thin streaks that drape across the southern sky. Wide-field cameras retrieve globular clusters on wild orbits that serve as test particles for the galaxy's gravitational field. Their motions confide where the mass hides, much of it invisible. The updated map does not end with the last counted star. It tapers into a domain where stars are sparse but gas is plentiful, where the invisible scaffold of dark matter dictates curvature and reach. Radio astronomers return with sharper ears. They catalogue high-velocity clouds whose metallic recipes vary, some tasting of the disk, some tasting of primordial simplicity. Some clouds seem to be falling, others rising, many shepherded by magnetic fields into long boomerangs. The Magellanic Stream drapes a colossal ribbon across a quarter of the sky, a fossil of interaction between the Milky Way and its bright companions. Its chemistry reveals a mixed origin, both stripped and carried, both donated and stolen. The cartographers learn to read such ribbons as both boundaries and bridges, lines that demarcate and connect at once. The atlas earns revision with each new wavelength. In gamma rays, paired lobes billow from the central regions, reaching tens of thousands of light-years above and below the plane. Their edges nibble into the halo, testifying to past eruptions that stirred the circumgalactic medium like spoons in a patient soup. X-rays accent the same shapes with hot borders. Microwave maps whisper of synchrotron haze. Each messenger adds relief to the portrait. The halo is not a static crown. It is a weather system, gusted by feedback, calmed by cooling, organized by the deep gravity of a dark structure that does not glow. Cartographers refine definitions while resisting the comfort of premature edges. Some adopt a virial radius, the distance where matter becomes bound in a dynamical sense for a given overdensity threshold. Others experiment with a splashback concept, a radius where infalling material reaches first a apocenter and piles into a faint edge. These are useful conventions rather than truths. The working map remains empirical. Kinematics, chemistry, density, temperature, all stitched together into a living contour. The result speaks of a frontier that advances and retreats, a seasonal coastline carved by tides of inflow, outflow, and merger. New apprentices join with new tools in hand. Machine learning sifts patterns in the clutter of positions and velocities, finding associations that human intuition might overlook. Simulations grow from small boxes into cosmological runs that birth galaxies by the tens of thousands, each one a laboratory for what a boundary might resemble. Observers compare these virtual halos to the measured streams and hot gas columns. Agreements tighten. Disagreement direct attention like lanterns hung over uncharted marsh. The atlas thickens, not toward finality, but toward fidelity, page after page of provisional accuracy that honors the complexity of what is being drawn. The cartographers of the halo do not stand in a single place. Some sit at consoles that listen to space in ultraviolet. Some pull all-nighters in high-altitude domes where frost forms on railings. Some breathe air that smells like ozone, inside control rooms that steer arrays of radio dishes across deserts and plains. Each group draws a layer, then checks it against the others. The work resembles weaving more than drafting. Threads of starlight, threads of absorption lines, threads of kinematic streams, threads of hot plasma, all interlaced into a fabric that can hold weight. At the end of a long century of mapping, the picture is confident enough to guide a traveler. The Milky Way has no hard rim. It wears a stellar halo GPS mapped by streams and clusters. It breathes through a circumgalactic medium that extends far beyond the last visible stars, a reservoir warm and hot, metal-laced and dynamic. Its gravitational personality is set by an unseen halo of dark matter that overshoots the luminous disk by a generous factor. The cartographers do not close the book. They leave blank margins where new rivers and new clouds will certainly be drawn. The map is not finished. It is finally honest. Shock arrives as a correction to instinct. A galaxy should behave like a city at night, brightness fading to neighborhoods, then to countryside, then to fields where the lights finally stop. Instead, the measurements refuse that simplicity. The outskirts teem with structures that do not dim in a tidy way. Velocities outrun expectations. The curve of rotation refuses to sink when stellar light grows scarce. Gravity acts as if more mass exists than all the counted stars and gas combined. The inference changes the emotional geometry of a galaxy. It is not a lantern with a lampshade. It is a lighthouse surrounded by an unseen promontory whose reach sets the rules for every orbit. Another assumption fails under scrutiny. If luminous matter writes the visible script, then the faintest chapters should be thin and uneventful. Yet the circumgalactic medium carries more than a footnote. Ionized oxygen glows in X-rays. Ultraviolet absorption lines bite into quasar light, revealing columns of hot and warm gas that hold a significant fraction of the galaxy's ordinary matter. The revelation upends the bookkeeping of cosmic inventory. The missing baryons, long suspected to be hiding somewhere, do not reside entirely in intergalactic highways far away. A large share floats in the galaxy's own weather, stretched into a sphere far larger than the starry disk. The idea that a galaxy is simply the place where its stars live collapses. It is also the long breath that surrounds them. Edges misbehave. If a boundary is a line, then the sky should announce it with a measurable cliff. Astronomers search for a star count that plunges decisively, for a temperature that flips from hot to cold at a radius, for a metallicity that jumps like a shoreline. Instead, they encounter gradients that stretch for hundreds of thousands of light years. Composition tapers, density slackens, temperature slides. Even the notion of being bound is ambiguous. Particles fall inward, pause, and drift outward again, building a population that is neither truly captive nor truly free. This region of first apocenter earns a name that sounds like a promise. Observations find hints of it, not as a cliff, but as a delicate ripple in the sea of tracers. A galaxy, it seems, does not end. It changes tense. The list of surprises extends to the archaeology of motion. Old stars wander through the halo in streams that should have been erased by time if the outskirts were chaotic. Their survival announces a paradox. The environment is violent enough to shred small galaxies into ribbons, yet ordered enough to preserve those ribbons for billions of years. Gravity behaves like a sculptor, with both a chisel and a glass case. The shock is not just about mass, it is about memory. The outer galaxy remembers more than its bright interior reveals. The central engine contributes an unexpected punctuation mark. Gamma and X-ray maps show immense lobes rising from the inner regions, as if a buried heart had exhaled with force. Their edges tug at the halo, imprinting hot borders and subtle turbulence. A galaxy is not only a receiver of material, it is also a sender. Outflows launched by star formation and by the black hole's temper climb into the outskirts and stir the circumgalactic medium for eons. The surprise is temporal. Events that occur near the core write legible sentences far from the core, long after the fireworks fade. The frontier is not distant in consequence, even if it is distant in miles. Even the simple question of how fast one must travel to leave reveals disquieting complexity. Escape velocity should follow the curve of visible matter. Instead, it lingers high, evidence that the invisible halo stretches far beyond guessed boundaries. Hypervelocity stars thrown from deep gravitational encounters act like probes. Their trajectories refuse to unwind quickly. The speeds required to be free remain large well past the last bright clusters. Unseen mass insists on its jurisdiction far from the courthouse. A traveler looking for a clean break will discover that departure is more like wading through a very long, very shallow surf than like stepping from a pier into open sea. Temperatures insist on strangeness. Gas that is thin enough to boast only a few particles per cubic meter is hot enough to boil a planet's atmosphere if brought near it. The juxtaposition is counterintuitive. Heat here is not the fever of crowding but the energy of broad, slow motion. Shocks from past outflows, gravitational stirring, and infall along the surrounding web elevate particles to energies that make quiet space behave like a whispering furnace. A galaxy's surroundings are therefore both gentle in pressure and fierce in temperature. Engineering intuition struggles, nature shrugs. Chemistry delivers another corrective. The halo is salted with metals, proof that it has been touched by many cycles of star birth and death. Yet pristine pockets persist, poor in heavy elements, and hinting at fresher infall from the cosmic web. The coexistence of enriched and primitive gas at similar distances confounds any expectation of uniformity. Mixing is incomplete. Circulation is patchy. The environment is a mosaic rather than a smooth gradient. Models must account for clumps that rain down, fountains that rise, and tides that stretch. The edge is an unruly kitchen with many pots simmering at once. Magnetism introduces subtlety. Fields thread the outskirts and lend structure to clouds that would otherwise shear apart. Cosmic rays ride these fields and help move energy and momentum through tenuous space. The effect is not loud, it is persistent. Over millions of years, gentle pushes accumulate. Clouds are stabilized or redirected. Jets find preferred lanes. The halo becomes less a formless reservoir and more a medium with a faint grain. This hidden grain shapes how gas is delivered back to the star-forming disk, how long it lingers, and where it prefers to cool. Kinematics overturns the comfort of symmetry. Tracers do not orbit as if the mass were perfectly spherical. Anisotropies emerge. The dark halo appears flattened or triaxial, tilted relative to the luminous components. Streams precess in ways that only an asymmetric potential can produce. The result is a second shock layered atop the first. Not only is most of the mass invisible, it is also arranged in shapes that resist easy description. The map must be three-dimensional and patient enough to capture slow twists. The notion of an edge that is a circle on a sky chart is abandoned. Boundaries, if that word must be used, are lopsided and alive. Timescales dilute intuition. Processes that build the outskirts unfold on millions to billions of years. Feedback cycles from star formation, the cooling of hot plasma, the sinking of satellite remnants, the infall of cosmic web filaments, all overlap with different rhythms. The frontier is composed of interference patterns between those rhythms. Observers taking snapshots at a single epoch see only a phase of a long song. The shock here is philosophical. Certainty collapses when the subject is too slow for impatient curiosity. Patience becomes an instrument as critical as a telescope. Scale amplifies the sense of redefinition. The stellar disk might span 100,000 light-years. The region influenced by gravity and enriched by circulation stretches several times that. The numbers are not ceremony. They change where a traveler would say inside or outside. They change what must be carried to survive. They even change the predicate of identity. If a significant fraction of a galaxy's ordinary matter lives in its atmosphere, then the galaxy is as much air as ground. The city metaphor dies, replaced by the image of a vast forest whose canopy, understory, and soil exchange nutrients across quiet distances. A single trunk cannot describe the whole. Information from background beacons needles this new picture into place. Light that crossed the halo on its way to a telescope arrives with signatures that act like stamps in a passport. Each stamp speaks not of a checkpoint, but of a crossing through a different parcel of gas. Some parcels are cooler and rich in certain ions, others are hotter and poor. The pattern defies a uniform border. It promises a complexity that still has the courtesy to be measurable. The shock softens into gratitude. Nature is complicated yet consistent enough to be charted. The final reversal is psychological. The notion of leaving a galaxy as a clean gesture is replaced by the idea of graduating through layers of relation. The outskirts are not failures of structure. They are where structure converses with its environment. The discovery is scientific and human at once. It asks that definitions adapt to what is measured, not the other way around. It asks that boundaries be drawn with pencils light enough to erase. A galaxy becomes a verb with many adverbs, each one describing how it holds, releases, heats, cools, remembers, and forgets. Shock clears the path for that grammar. Gravity gathers where light refuses, shaping a volume that outlives any lantern of stars. Around the bright wheel stretches a cocoon of influence that does not shine, yet dictates the terms on which the luminous parts can exist. It is felt in the stubborn flatness of rotation curves, in the hard cost of escape, in the way streams keep their arcs. Simulations begin with this invisible sea as the stage, a bath of particles that interact rarely, move swiftly, and pile into structures from the earliest times. In the mathematics, small ripples grow, merge, and settle into halos that cradle galaxies like seeds held in gloved hands. The shape of that glove is not perfect sphere, but softened geometry. Early constructions favor a cusped profile where density steepens toward the center, a gradient that bends orbits into tight spirals. Later, refinements find that gentle curves fit better, slopes that ease from inner regions to the outskirts. Parameters acquire meanings beyond numbers. Concentration whispers of how quickly the halo assembled. Scale radii speak of where the balance between inner crowd and outer hush is struck. Out to hundreds of thousands of light years, the profile declines, yet slowly enough that the reach of the halo sets the horizon of belonging far beyond the brightest ring. Within this embrace reside sub-halos, little knots of gravity like islands in an unseen archipelago. They are leftovers from the universe's patient construction, building blocks that never dissolved entirely. Some carry dwarf galaxies as cargo, others are dark shells adrift with no star to betray their presence. Their tug alters the handwriting of stellar streams, carving kinks and gaps that behave like fingerprints. The presence of many small tugs tells a story about the nature of the unseen. A population rich in substructure argues for particles that are cold, with low primordial speeds, allowing clumps to survive and travel intact into the present. The luminous disk is not merely a passenger. Its mass steepens the inner potential, and the halo responds. Orbits contract, orbits heat, the central density shifts slightly, a negotiation between hot memory and cool infall. Feedback from starbirth and black hole temper can push the other way, stirring the center and diluting an inner cusp into a core. The final structure is a compromise written over billions of years, an average of many tempers. When stars, gas, and dark mass reach a truce, the halo's curve sets the rhythm of everything that orbits within it. Simulated universes serve as laboratories where the truce can be rehearsed. Boxes of artificial cosmos expand, cool, and grow filaments that funnel matter into nodes. At each node a halo blooms, then splits and braids under the pressure of mergers. The grand runs give galaxies by the tens of thousands. Smaller, sharper calculations place a single system under a microscope, resolving the dances of satellites, the fountains of wind, the rain of cooling clouds. When the model agrees with maps of streams and velocities, confidence rises that the unseen scaffolding has been traced with some fidelity. The halo is not quiet. Large companions sculpt it in slow motion. A massive neighbor carves a wake as it passes through the sea of dark matter, a low-pressure trough that pulls on outer stars and tilts their paths. The reflex of the host is not trivial. A whole galaxy nods in answer to the footfall of a satellite, and the nod propagates to the edge. In that nod, escape becomes a moving target. The splashback ripple shifts, and the orbits of globular clusters precess with a memory of the encounter. Anisotropy lives in the velocity field of halo tracers. Motions are not evenly split between radial and tangential. Some regions are dominated by long excursions that dive toward the center, then climb back out. Others circle with modest eccentricity. The mix encodes history. Early violent assembly produces hotter, more radial populations. Later, smoother accretion yields cooler, more circular motions. By decoding the balance, one infers the tempo of growth, the seasons when the galaxy feasted, and the intervals when it sipped. The geometry itself can be skewed. Dark halos prefer ellipsoids, with subtle stretching along one or two axes. The luminous disk slowly rounds the inner parts, but the outer regions keep their tilt. Streams wander like ribbons in wind, and their twists record the shape of the gravitational field. No compass can capture this directly. Stars must be followed like migrating animals. Their tracks converge on a conclusion that the embrace is lopsided, a quiet asymmetry that only long patience reveals. The unseen might be made of massive particles that feel only gravity and a feeble whisper of other forces. It might be composed of lighter quanta that behave like waves on galactic scales, smearing out cusps into soliton-like cores. It might be a melange with sterile flavors or an axion field that condenses into a soft, cool halo. Each possibility tends to leave characteristic structures. Clump counts, density slopes, core sizes, heating of streams, lensing signatures around distant galaxies all act as riddles whose solutions point to a particle identity. A Milky Way halo becomes part accelerator, part cloud chamber, part archive. The edge of influence hosts a slow negotiation between bound and becoming unbound. Material falls along filaments, reaches a first apocenter, and lingers. The linger steepens the density slightly, a delicate crest in a long swell. Outflows reach this shoreline with debris carried from the interior, metals that taste of prior cycles. Some of the freight sinks back, some escapes along paths of least resistance, some hangs in limbo for eons. When maps are stacked carefully, a faint sketch of this rim can be traced, not as a wall, but as a gentle fold where trajectories turn. Within the halo, the temperature portrait of normal gas is layered. Hot plasma fills large volumes at million-degree energies. Cooler clumps hide inside it, their densities high enough to radiate efficiently, their sizes small enough to be mistaken for silence. Magnetic fields thread the mixture, guiding cosmic rays that carry momentum without mass. Over long periods, these agents redistribute energy, letting gas drift inward to be reborn as stars, or pushing it outward during seasons of frantic birth. The halo moderates. It is a thermostat that cannot be unplugged. Dynamical friction acts like a brake on massive satellites, translating orbital motion into a faint heat in the sea of dark matter. As a dwarf galaxy or a globular cluster spirals inward, it leaves behind a trail of stirred particles. That trail is a wake that other tracers can feel. The map of such wakes, if seen in enough detail, becomes a method to weigh the invisible fluid. Measuring the break allows a measure of density, and density is the language that reveals how tightly the embrace holds. Star formation rates inside the disk are tied to this outer treasury. Gas that trickles in sustains new generations, while gas expelled during hectic times cools along the way and returns later as a quieter rain. The pace is not constant. It varies with the rhythm of mergers and with the lungs of the halo. When the reservoir is deep and stable, the disk glows steadily. When the reservoir is hot and stirred, the disk dims and waits. The halo is therefore a memory and a forecast, holding both the ashes of prior fires and the oxygen of those to come. Potential alternatives to an unseen sea have tried to distribute the load to gravity itself, adjusting the law so that at low accelerations it behaves with more leverage. Such adjustments can mimic the spin of disks with elegant economy. Yet the outskirts demand more than spin. They ask for substructure that kicks streams, wakes that satellites carve. The full three-dimensional conversation between satellites and host. Each demand is a test. So far, the landscape of evidence keeps favoring an invisible population with mass, a cold and patient majority that neither shines nor shouts. The embrace extends beyond parochial power. It links the galaxy to its environment, aligning with the nearest cosmic filaments and tilting the preferred lanes of infall. Satellite galaxies tend to arrive in planes that echo those filaments. Globular clusters on long tours trace the same alignments. Motion, shape, and supply all conspire to reveal that a halo is not only a container, it is an intersection where larger rivers meet. At that intersection, identity is not closed. The unseen sets the junction's geometry and keeps it open across time. When a lone traveler reaches the threshold where starlight thins, the invisible still rules. The pull felt in the bones of a craft, the long pedigree of the escape curve, the faint shiver of a passing sub-halo, all belong to the same presence. It is not a cloak stitched to the galaxy, it is the frame. Within that frame, the disk can spin, bars can buckle, spiral arms can whisper their density waves. Outside that frame lies only the larger web that made it. The dark halo's embrace is not a metaphor, it is the architecture of permission. Rivers arrive without water, but they flow all the same. Long and pale, they thread the sky with the patience of glaciers, carrying stars that were once bound to smaller homes. Each ribbon begins as a compact companion, a dwarf galaxy or a globular cluster that wanders too near and feels a tide that does not care for sentiment. Gravity pulls harder on the near side, gentler on the far, and over many passes, a quiet unspooling begins. What had been a single flock becomes a caravan stretched along its orbit, a memory made visible. These streams are archives written in motion. The leading arm runs ahead, the trailing arm lingers behind, and the two together bracket the lost core like quotation marks around a vanished sentence. Some are razor-thin, the work of clusters with little internal gravity. Others are broader and ragged, the legacy of dwarfs with their own star-forming histories. Curvature tells the story of orbit, density ripples hint at the heartbeat of the parent, and width betrays the warmth of the birth system. The sky becomes a palimpsest, where new rivers overlay older ones and cross at gentle angles, a testimony to the crowded diplomacy of the halo. Shells appear where streams come from more radial incursions. A small galaxy dives inward, sheds stars near pericenter, then swings out again until motion slows and material piles up. The pile brightens as a faint arc, a ripple that wraps the host like the shy echo of a bell. Successive passages produce nested arcs, each one a timestamp that can be read with the right mathematics. Together, shells and streams reveal the diversity of accretion. Some arrivals were tangential and survived to spiral slowly. Others were headlong and brief, their bodies transformed into luminous contour lines. Chemistry adds a second layer of cartography. Stars brought in by a dwarf often carry lighter fingerprints of heavy elements than those born in the large disk. Some belong to families enriched by slow processes, others by quick ones, and the mix acts like a surname. By tracing metallicity along a stream, one can identify not only the parent, but the sequence of star formation that once occurred inside it. The river becomes a biography. Early generations glimmer with low metallicity. Later strands show the alchemy of supernovae, written into their iron and alpha elements. Even globular cluster streams keep a consistent flavor, tighter in chemical space than the broad diet of the halo. In that precision, the hand of origin is still visible. The mystery deepens as the rivers are measured with exact astrometry. Motions in the plane of the sky, radial velocities along the line of sight, and distances woven from variable stars combine into six-dimensional paths. In that full-phase space, streams look less like lines and more like filaments stretched across a contoured potential. Some curve as expected, others kink, fan, or fork. The culprits vary. A passing lump of invisible mass pushes briefly on one section, leaves a gap where stars would have been, then the edges curl inward like torn paper. A bar within the bright disk nudges at resonant longitudes, changing the tilt of the downstream current. A massive satellite shifts the center of pull for a time, and the whole river reorients by a few delicate degrees. Action angle variables turn the filaments into straightened strands inside a transformed space where each coordinate represents an integral of motion and each angle runs with a steady pace. In that diagrammatic clarity, one can spot disruptions with ease. A gentle bend means a long tidal exposure. A sharp deviation marks an impulsive encounter. The technique allows a traveler of mind to reconstruct accidents that happened hundreds of millions of years earlier. Streams thus become forensic tools. They reveal the hidden geography of the gravitational field, and they expose the population of small perturbers that leave too little light to announce themselves directly. Gas tells a parallel tale, but with different grammar. The Magellanic Stream is a ribbon of neutral hydrogen that spans a large swath of sky, a tide torn from bright companions by long intimacy and ram pressure, a river of atoms rather than stars. It testifies that not all stripping processes bequeath stellar leftovers, and not all interactions finish quickly. Shades of metallicity along its length betray mixed origins, some parcels older, others younger, all of it shaped by a wind from the hot medium that wraps the host. Where gas and stellar streams overlap, the conversation becomes richer, contrasting the fate of diffuse clouds with the stubborn persistence of starry beads. The presence of rivers hints at the patience of the halo. If the outskirts were fully turbulent, ribbons would smear into fog within a few orbits. That they remain coherent implies a large-scale order that lasts for ages. Yet coherence is not uniform. Some streams fan into veils as if the potential were triaxial and tilted, so that stars released at slightly different phases are sheared into a spread of directions. Other streams roll into narrow plats, evidence that the local field is near spherical and quiet. The variety sketches a map of symmetry and its gentle violations. Outer space here is not generic, it has character. Clumps hidden within the unseen sea leave their mischievous signatures. When a small dark subhalo grazes a stream, the encounter moves stars aside and produces underdensities that widen with time. Multiple hits pepper a long river with a dotted cadence. By counting the dots and measuring their sizes, one estimates how many clumps roam at a given mass. The numbers turn into a test of what the dark majority can be. If the clumps are fewer or smoother, the underlying particle may be warm or wave-like. If the clumps are many and sharp, the particle may be cold and heavy. The river becomes an experiment that never had to be built. It was seeded by galactic history and waits to be deciphered. Sometimes a stream seems to break its own rules. A caravan that should track a perfect orbit is offset from its putative progenitor, or it carries stars with a spread in energy that does not match a tidy tidal origin. Such puzzles often point to misidentified parents, or to interactions that retuned the kinematics after birth. They may also signal multiple episodes of stripping, where different passes contributed distinct wraps. The sky records each wrap as a parallel filament, slightly displaced, slightly older. When those layers are separated, the timeline of the family appears with startling clarity. The largest satellites create grander reactions. A heavy companion moving through the halo drags a wake of dark matter that in turn pulls on streams across wide sectors. The wake is invisible by itself, but streams acted upon by it curve like reeds in a slow current. The effect is subtle in any one ribbon, but coherent across many. A global analysis becomes possible, where dozens of rivers together feel the same broad tug and thereby reveal the mass and motion of the disturber. The outskirts thus become a network of sensors, each sensitive to a different component of the same passing event. Light echoes of past feasts can be faint as sighs. Deep imaging reveals umbrellas of stars around distant analogues, their arcs highlighting the moments when small galaxies were converted into structure. By analogy, the local rivers fit a universal script. Galaxies grow by eating gently and often, and they keep the napkins. The napkins are the streams and shells, stained with chemical clues and folded into clean symmetries or crumpled by perturbations. To read them requires both persistence and a refusal to accept smoothness where none exists. Beyond their diagnostic power, the rivers teach a philosophy of motion. Objects in a big potential live on paths rather than places. Identity for a small system is not a fixed address, but a trajectory and a dispersion around it. Given time, even identity is shared. A dwarf gives its stars to the larger host, and those stars, once citizens elsewhere, vote in a new polity. The halo is the town square where such migrations are most visible. A single field of view can hold members of multiple ancestries, passing through that patch as part of different tapestries. The scene is quiet, yet the politics of gravity are alive within it. A solitary watcher who holds long exposure eyes on one of these rivers sees almost nothing move, and yet nearly everything is in motion. The slowness is a trick of scale. Every star is falling and climbing along a narrow valley of the potential. Every clump is testing the fabric with its passing. Every shell marks a pause so long that it mimics permanence. The lesson is that permanence here is a cadence too wide for quick impressions. The streams preserve that cadence. They make motion legible for those willing to stack years into decades and decades into surveys that listen rather than shout. The more rivers are traced, the less convincing any simple boundary feels. Each new filament reaches farther, or curls at a radius thought already quiet, or carries metallicities that argue for both youth and age. The frontier becomes a delta, a place where many branches braid and unbraid, where shores are made and remade by slowly changing flows. To travel that delta is to learn that a galaxy is defined not by what it contains today, but by the conversations it is having with what moves around it. Rivers of tidal memory are those conversations, paused into visible lines. Breath leaves a galaxy and does not vanish. It climbs into space as wind, slows into haze, cools where pressure falls, and lingers in a sphere so large that the luminous disk looks like a kernel inside a husk of air. The air is not breathable. It is a blend of ions at temperatures that make the idea of heat feel different. Here, heat is not closeness, but energy stored in vast, thin motion. The circumgalactic medium stretches across hundreds of thousands of light years, faint in brightness, yet loud in consequence. It moves metals from nurseries to wilderness, catches rain from the cosmic web, and keeps score of every outburst that the galaxy has ever allowed. Its structure is layered. Hot plasma near the virial temperature fills most of the volume, a 1,000,000-degree bath, sparse enough that a teaspoon would hold near nothing. Within that bath drift cooler clouds, some only a few thousand degrees, others at a middle regime where oxygen is 5 times ionized. The phases intermingle along skins of shear, where heat leaks and turbulence writes filigrees. At those contact surfaces, the gas creates ions that tell on themselves when backlit by distant lighthouses. One line speaks for warm gas, another for hot, each a byte in the continuum of a quasar. The bytes repeat across many sightlines until an image appears, not as silhouette but as a census of columns. This breath is not static. The disk sends material upward when clusters of stars explode in chorus. The fragments race along chimneys carved by previous eruptions, then billow into the halo as fountains. Some fragments cool and drift back as clouds that fall like slow hail. Others stay aloft for a geological patience, mixing metals throughout the volume. A central engine can add its punctuation to this cycle, pushing by conical flows that open cavities and seed shocks. Even long after the driver quiets, the cavities persist, wrapped in shells of hotter gas that remembers the impulse. The medium records both kinds of wind, one from star birth, one from the black heart, and it folds their stories together into a common weather. Cooling does not proceed evenly. Where entropy is low enough, small perturbations grow into condensing knots. A seed of extra density loses energy faster, grows denser still, and steps down a ladder of temperature until hydrogen can exist in a neutral state. In other places, heat from the surrounding bath diffuses in faster than radiation can remove it. There, the seed evaporates before it can take a first breath. The border between these destinies defines a precipitation threshold, a contour where gravity, pressure, and temperature arrive at a truce. Across that contour, clouds form, then are torn by flows, then reform. The medium learns to make rain intermittently. The survival of any one cloud depends on an argument between crushing and protection. A wind can shred a clump in a few dynamical times. Conduction can erase its cool core. Turbulence can stretch it to a veil so thin that it dissolves into the background. Yet, magnetic fields can drape around its skin and slow the exchange. Cosmic rays can press from within and distribute momentum without boiling the gas. Radiative skins can cool enough to rebuild the core after a partial loss. Survival becomes a balance of small forces, acting for long intervals. Observers infer this balance when they find cool clumps at radii, where theory once predicted only heat. Dust is not absent. Grains ride out with winds and absorb ultraviolet light, then re-emit at longer wavelengths. Some are destroyed in shocks, some are sputtered away in the hot bath, and some persist long enough to join the rain that feeds the disk. The inventory of dust outside the bright plane is small compared to the interior, yet its presence matters. Grains provide surfaces where molecules can form. They help set how efficiently gas cools and how quickly clouds gain mass. Even a sparse seasoning of carbon and silicate changes the recipe of condensation. Satellites moving through this environment feel deterrents at the edges of their own small atmospheres. Ram pressure strips gas from dwarfs as they plow through the halo, quenching star formation and leaving tails that point away from their path of travel. Those tails curl and mix, seeding the medium with pockets that have different chemical tastes. When a satellite is massive, the exchange can proceed in both directions. Material from the host is deflected and wrapped around the intruder. The encounter leaves trails that are part donation and part theft, turning the space between galaxies into a marketplace of slow trades. Evidence for the breath arrives from delicate signals that ask for patience. The ultraviolet reveals doublets that favor warm, ionized parcels. X-rays reveal oxygen in forms that require much higher energies. Microwave maps show a faint pressure signature where hot electrons distort the sea of ancient radiation. The distortion is tiny, yet coherent across the sky wherever galaxies gather. Together, these tracers measure density and temperature without the need for direct glow. They weigh the medium and show that its mass rivals or exceeds the mass locked in stars. A galaxy is therefore not only a collection of suns and planets, it is also a reservoir. Motion inside this reservoir is not random. Circulation sets up preferred paths. Gas that arrives along cosmic filaments glides through the outer halo with memory of its origin. Angular momentum is imperfectly shared. Some parcels dive on radial lines, reach a turning point, then rise again to hover near apocenter. Others spiral slowly, skimming closer to the disk with each revolution. Outflows ride opposite lanes, often along polar directions where resistance is lower. The two streams interleave like opposing traffic. Where they meet, mixing layers bloom. Those layers host the ions that make absorption lines most conspicuous. Time manages the cadence. Fountains launched by star formation can take hundreds of millions of years to complete their loops. The black hole speaks in rare, loud syllables that shape the halo for tens of millions of years after each syllable fades. Infall from the web has rhythms tied to the growth of structure, with long droughts and brief pulses. The medium sums these scales without irony. It keeps imprints from each and turns them into a climatology. A scientist reading this weather can foretell whether the disk will be fed steadily or starved until the next tide arrives. Geometry matters. The halo is not perfectly round. The distribution of gas is thicker along some axes, thinner along others, often aligning with the orientation of the dark structure beneath. Bubbles and cavities sculpted by past outflows bias pathways much later, acting as low-density tunnels. Satellites and their wakes add asymmetry that persists for ages. A traveler moving through this realm would find that the local weather repeats on long chords, with corridors of reduced drag and zones where cooling has seeded chains of clouds like beads on a wire. Navigation would be a study in pressure gradients rather than landmarks. The medium carries a record of the metal budget. Each heavy atom in the halo once came from a star, findable in lines that prefer specific temperatures. By totaling those lines across the sky, one estimates what fraction of forged material escaped the disk and how much was retrieved. The answer depends on mass and epoch. Heavier galaxies keep more of their metallurgy. Lighter ones vent more into space. Over time, the halo drifts toward enrichment, yet with stubborn patches of primitive gas that likely arrived from farther out. The resulting mosaic denies any singular narrative. It says that growth is a dialogue between inheritance and import. Fast pulses from remote cataclysms cross this reservoir and arrive with dispersion that encodes the number of electrons met along the path. Each pulse acts like a sonar ping. When many pings are collected, a three-dimensional estimate of electron density becomes possible. This new map-making joins the older methods and fills gaps where quasars are scarce. It confirms a long suspicion. The breath is thickest where gravity is deepest, and it thins gently toward the edge where the galactic pull yields to the basin shared with neighbors. The threshold between a galaxy's air and the space between galaxies is soft. At large radii, the temperature and density join values common in the surrounding web. Filaments touch the halo and thread through it, bringing in material that has never known a star and taking out metals that will seed distant condensations. There is no fence, there is only an exchange rate. During quiet epochs, the exchange favors gentle inflow. During active epochs, it favors outflow. Seasons last longer than civilizations. The ledger balances only across epochs that dwarf memory. Breath is often invisible, yet it moves every future. Stars form when gas cools and collects. Cooling depends on what the medium holds, how it is stirred, and whether the thermostat of feedback has been set high or low. The circumgalactic reservoir is therefore not a backdrop, it is the manager of supply. Its decisions are incremental, made by physics without preference. And yet the sum is a policy. By the time a new generation of suns kindles, the policy has already been written in the faintest corners of space around them. A solitary vessel that drifts through this realm would feel no wind on a hull. It would feel only a slow change in required thrust, a difference in drag so slight that instruments must gather it over years. Sensors would taste ions in counts per second, so modest that patience must be the primary power source. Yet the data would compile into a portrait grander than any image of the bright disk. The traveler would learn that the fate of luminous structure rests in matter that barely glows, in breath that climbs, cools, stalls, and returns. Between galaxies there is an atmosphere, and in that atmosphere the future waits. Escape is a sentence written in speed. The grammar is simple to state and hard to satisfy. A traveler must carry enough kinetic energy to balance every debt called in by the galaxy's pull. If the sum of motion and potential climbs above zero, the path opens into infinity. If not, the arc folds back, and the traveler returns on a different chord of the same song. The threshold is called escape velocity. It is not a single number. It changes with distance from the center and with the hidden architecture of mass that surrounds the luminous disk. In the neighborhoods where suns keep company, the threshold is fierce. Figures on the order of hundreds of kilometers per second describe the price of freedom. Farther out, where the pull slackens, the price drops, though never to nothing. The invisible scaffold of mass stretches the bill far past the last bright spirals. The shape of that scaffold can be read by collecting the fastest bound stars and asking how high they can run without breaking loose. The answer, folded into statistics, yields a curve of escape speed as a function of radius. That curve is discovery translated into a map. Some stars do not ask politely. They flee with velocities beyond even the upper tail of the normal distribution. A few cross the threshold entirely and sail outward on trajectories that will never return. Their existence is a lesson in gravitational drama. One mechanism occurs near a massive central object where a binary wanders too close. The pair is torn apart. One star is thrown inward to a tight orbit or swallowed, and the other is slung outward with a gift of speed that can exceed 1,000 kilometers per second. Another path begins in crowded clusters where three bodies fall into a brief dance. The lightest partner is given energy at the expense of the other two and is ejected with a reckless pace. A third path follows a supernova that detonates in a binary. The survivor is suddenly freed from a companion that had been holding it in place. The release, plus the impulse from the blast, turns a modest orbit into a runaway voyage. These runaways become accidental probes. Their motions trace the shape of the gravitational field through which they travel. As they climb, their speeds decline according to the energy they spent to leave. If the decline is gentle, mass reaches far. If it is steep, mass lies closer in. By sampling many such trajectories and folding them into models, one infers the depth and breadth of the unseen halo. In this way, a violent origin yields a quiet measurement. Every hyperfast star is both a story and a survey. For a crafted vessel, mathematics becomes engineering. The rocket equation enters with its stern reminder that propellant mass climbs exponentially with the desired change in velocity. Traditional chemical fuels wilt under that demand. Even nuclear fission strains to deliver more than tens of kilometers per second without exotic staging. Fusion offers hope, with projected exhaust speeds high enough to put hundreds of kilometers per second within reach if mass ratios can be tamed. Antimatter promises more, but scarcity and handling temper its dream. Beamed propulsion sidesteps some of the burden. A light sail pushed by ground or orbital lasers could be given its speed without carrying fuel at all. If a sail reached a few percent of light speed, escape would be trivial. The problem would cease to be the Milky Way and become intergalactic scale. Gravity assists are a time-honored tactic within planetary systems. Around stars, they are possible in principle, but the geometry is unforgiving. To gain a meaningful share of speed from a star, a craft must dive dangerously close, where tides, heat, and radiation sharpen into peril. A pass near the central black object would multiply both the risk and the reward. Energy can be stolen from a spinning giant through clever orbits, yet the slightest error would end the mission. Safer assists might be harvested from massive companions on wide loops, but the dividends would be modest. In practice, the better course is to buy speed honestly through propulsion and spend it frugally along a clean outbound trajectory. Navigation must respect tides and time. An orbit tilted steeply to the disk reduces the number of crossings through crowded lanes of stars and gas. Each crossing adds a small probability of encounter with debris and increases integrated radiation from the thin, hot components of the galactic atmosphere. An outbound path aimed through regions of lower density minimizes drag that is already tiny but not literally zero. The cumulative effect over millions of years can matter for small objects that travel near the threshold. A margin of extra speed at the start is a kindness to the future. Radiation weighs into design as surely as fuel. Outside the shield of a magnetic heliosphere, cosmic rays arrive without much moderation. A galaxy's outskirts add little material shelter, but also little additional hazard. The flux is set mostly by the large-scale environment and occasional storms from nearby activity. Protection becomes a matter of mass and structure. Water absorbs well and doubles as life support and reaction mass. Magnetic fields built into a hull can deflect some charged particles. For unmanned craft, electronics must be hardened and redundant. For living travelers, biology must be managed like an experiment, with repair and recycling as central as thrust. Communication loosens as distance increases. A craft that climbs toward freedom quickly outruns the comfortable cadence of round-trip signals. Minutes become hours, hours become days, then months. Autonomy is not an option. It is a requirement. The guidance of the vehicle must be a form of patient intelligence capable of rewriting its own priorities as the environment changes. Its sensors must be trusted to decide when to sleep and when to wake, when to measure and when to coast, when to whisper home and when to listen. Escape is not simply a burst of speed. It is a long practice in self-stewardship. Time dilates only modestly at the velocities needed for escape, unless true relativistic speeds are achieved. At a few thousand kilometers per second, clocks aboard and clocks at home differ by small margins. At a tenth of light speed, the difference becomes an element of mission design. Life support, materials fatigue, and sensor longevity must be planned in the frame that does the traveling. For robotic messengers, sustaining coherence over centuries becomes the hard part. For biological beings, sustaining meaning becomes harder still. The outer darkness offers silence as a companion, and even electronic minds require a diet of goals to keep curiosity from cooling into drift. Measurement of escape conditions is not only a tool for leaving, it is also a diagnostic of what holds the galaxy together. Surveys that gather the fastest stars in local neighborhoods build a speed distribution that tapers toward a maximum. That taper holds information about the total mass within a given radius. If the taper extends farther than expected, more mass is implied. If it ends early, less. Uncertainties accumulate from the age of the population, the degree of anisotropy in velocities, and the possibility that rare objects with extreme origins contaminate the sample. These uncertainties are not flaws. They are invitations to collect more data and to refine the picture of the invisible sea around the visible shore. There is a philosophical trace in the numbers. Escape feels like an intention, as if will alone could push a trajectory past the grip of a long belonging. Physics corrects that romance. Energy is the only intention the cosmos recognizes here. If the budget is sufficient, departure follows. If not, return is guaranteed. The same impartiality that frees a runaway star will also accept a humbled traveler back into orbit without malice. To plan a path outward is to accept this neutrality and to design within it. Margin, redundancy, and patience are the engineering names for humility. One can imagine a craft that begins far from the busy light of the inner disk. It chooses a poleward route, aims between the slow traffic of distant clusters, and runs its engine until the required reserves drop below a threshold set long before launch. The plume glows briefly around it, then fades as the reactor cools. Instruments watch the faint drag decline. The sky simplifies. The bright wheel narrows into an ornament. Speed and distance conspire to flatten the curve of the galaxy's pull until it feels like a memory of weight rather than weight itself. The craft does not celebrate. It measures, adjusts, and continues. In charts that reduce epochs to numbers, a subtle signature marks the crossing. The specific orbital energy becomes positive and stays positive. The coordinate distances grow faster than any turn can return them. The local escape speed curve drops beneath the craft's actual speed and remains beneath it. There is no trumpet at such a moment, only arithmetic and a quiet, irreversible change in the future set. The traveler has joined a class of objects that will not be called home by gravity alone. Escape velocity is not a wall. It is a threshold that gives meaning to momentum. The frontier it names is less a place than a promise that a path can continue without circling back. To reach that frontier requires a knowledge of what holds the galaxy together, an ability to read the fastest messengers, and a will to purchase speed through clever means. Past it, the distances do not care who crosses. They only offer room. The cost is high. The reward is time enough to see a galaxy shrink to a jewel and to watch the larger pattern around it come into view. Signals arrive from behind, like whispers through frosted glass. A bright lighthouse in the deep universe shines toward the observer, and on the way, its light passes through thin, extended gas that belongs to a nearby giant. The light arrives with small bites missing. Each bite is an absorption line at a wavelength that corresponds to a particular ion and a particular temperature. The pattern on the spectrum is a barcode for an atmosphere too faint to see directly. Magnesium, in a low state of ionization, marks cooler clumps. Carbon and silicon in higher stages reveal warmer skins. Oxygen in extremely ionized forms testifies to million-degree pockets. The collection turns a blank sky into layered weather. Quasars gift the clearest silhouettes. Their continua are smooth and loud, so when halo gas intervenes, the loss of light is easy to measure. A single line of sight is a needle threaded through a cathedral. Many needles create a quilt. As the sample grows, the covering fraction emerges. Some ions appear along most sight lines at a given radius, meaning that phase is widespread. Others appear only in patches, meaning that phase lives in islands. Column densities rise and fall with distance from the galactic center, with the metallicity of the host, and with its level of star formation. These dependencies are not academic. They reveal both the shape of the reservoir and the cadence of exchange between disk and sky. Distant galaxies also serve as backlights, though their starlight is knottier than a quasar's. By stacking many spectra, the knots average into a smooth lantern. The collective signal reveals absorption that would be too weak to trust in a single case. Stacking produces maps of average properties at large radii, where individual detections are rare. The maps are fuzzy but profound. They confirm that metals extend farther than expected if outflows were timid, and they suggest that cooling layers are common along interfaces where hot and warm phases mix. Some events offer pings rather than continuous beams. A brief explosion ignites in a remote galaxy and sends a pulse of radio waves sweeping outward. On its path toward a telescope, the pulse is slowed by free electrons. Low frequencies lag behind high ones, arriving later in a dispersion that scales with the total number of electrons encountered. The delay is small but precise. By subtracting the known contributions of the interstellar medium in the observer's own system and the expected fog between galaxies, The remainder can be attributed to gas nestled around intervening giants. Many pulses recorded along separate lines of sight become a new kind of tomography. The electrons sketch a three-dimensional portrait of where the halo is thick and where it thins into the shared basin among neighbors. Microwave photons from the relic background meet hot electrons in the outskirts and lose a sliver of energy. The loss imprints a spectral distortion known as a thermal pressure shadow. Around clusters, this shadow is bold. Around single galaxies, it is faint. With patient observatories and clever statistics, the faint becomes measurable. Stacking the microwave images of thousands of similar hosts produces a ring of altered temperature that marks the footprint of hot halo gas. A subtler effect occurs when electrons drift with respect to the background rest frame. Their bulk motion induces a temperature shift of both signs, positive on one side, negative on the other. The pattern hints at inflows along preferred directions and at outflows along chimneys carved in older epochs. X-rays leak from the hottest phase. Emission is a whisper because the gas is thin, yet the sky holds enough exposure time that diffuse glows around massive disks can be traced. The glow is not smooth. Cavities and edges appear where ancient outbursts inflated bubbles. Beyond emission, absorption from highly ionized oxygen is detected against the bright X-ray light of distant sources. Those lines constrain temperatures and provide a cross-check on masses inferred from other means. When ultraviolet and X-ray tracers are combined along the same sight lines, the layers of the medium can be ordered by temperature rather than guessed by theory alone. Polarized radio emission offers another key. As linearly polarized waves pass through magnetized plasma, their planes of polarization rotate. The rotation depends on the line integral of electron density times the magnetic field along the path. Measurements toward background sources near giant disks show rotation measures that fall with radius yet remain above zero out to large distances. The implication is that magnetic fields thread the outskirts, guiding cosmic rays and giving clouds skins of draped field lines. These skins help explain how cool knots survive their passage through hot baths, and why some absorption features persist where pure hydrodynamics would predict erasure. Gravitational lensing produces an indirect test of small-scale structure in the gas. In a few lucky systems, the same quasar is multiply-imaged by an intervening mass, creating two or more light paths that pass through slightly different parts of a foreground halo. When the absorption features differ between images, the difference sets an upper limit on the size of the absorbing clumps. Some are surprisingly small, on scales comparable to the distance between stars in a quiet neighborhood. Such sizes challenge expectations about cloud survival and force models to include magnetic support, cosmic ray pressure, or a fog of many droplets refreshed by turbulent condensation. Metallicity acts as a historian. The ratio of iron to alpha elements tells whether a population was enriched more by long-lived stars or by quick detonations. The strength of nitrogen lines traces contributions from intermediate mass stars. By reading these ratios in halo gas, one reconstructs the enrichment path that carried the chemistry outward. Some sightlines reveal nearly pristine gas, poor in heavy elements, and likely delivered along filaments from outside the system. Others are rich, implying that multiple cycles of birth and death in the disk have breathed their products far into the halo. The mixture tells of a long conversation between accretion and feedback. Kinematics is written into the shapes of spectral lines. Narrow profiles imply cooler, more quiescent conditions. Broad ones imply turbulence or multiple components blended by limited resolution. Velocity offsets, relative to the systemic speed of the host, point to flows. Blue shifts hint at outflows, red shifts at infall, though geometry complicates the translation. By collecting many sightlines and modeling the likely orientation of each host, a statistical pattern emerges. Young, actively forming disks tend to show more blue-shifted absorption along minor axes, consistent with wind. More settled systems show a balance or a tilt toward inflow along major axes where filaments deliver spin-aligned gas. The pattern turns a schematic diagram into a living economy. Gaps remain and provoke invention. The warm, hot phase that dominates the volume is best traced in X-rays where instruments struggle to collect enough photons at the needed resolution. New concepts push for calorimeters with fine energy discrimination that can separate lines from oxygen and iron, even in diffuse emission. The radio community seeks denser grids of background polarized sources to sharpen magnetism maps. Optical observers gather deeper stacks to push metal line searches to radii, where the halo blends into intergalactic space. Each advance reduces ambiguity and replaces painted edges with measured gradients. Transient beacons add a sprint to the marathon. When a massive star collapses in a far galaxy, its afterglow shines across the spectrum for days. If the timing is kind, a spectrograph can capture its light as it threads the halo of a nearer host. The resulting absorption snapshot gives a one-time probe of a line of sight that may never be backlit again. Such moments produce rare combinations of sensitivity and coverage. They reveal intermediate ions and molecular fragments alongside atomic lines. The variety tightens constraints on density, pressure, and the thickness of the mixing layers that surround cool clumps. Occasionally, the map gains depth through motion. A fast radio pulse that repeats allows multiple measurements through the same section of sky. If the measured dispersion varies, the change indicates evolution in the intervening medium. The timescales of such changes are long, but even upper limits are useful. They argue against clouds that drift apart quickly and for structures held in place by a balance of forces. Repeaters also improve localization, making it possible to connect dispersion directly to a known section of a halo with known properties in other wavelengths. All these signals redraw the frontier. There is no cliff where membership ends. There is a soft braid of temperatures, densities, and compositions that fades into the larger web. The braid retains fingerprints of storms from the interior and stamps of arrivals from beyond. The map that results is not an outline, but a set of overlapping transparencies. Taken together, they show that a galaxy's presence in space exceeds its light by a generous reach. They also show that identity can be carried by gas that has not yet shone and may never do so. In those quiet atoms, the next generation of bright structure waits for its cue. A traveler who chooses navigation by spectra rather than by stars would find strange comfort in this method. The path forward can be traced by the softness of dips in a quasar's continuum, by the faint skew of the microwave sea, by the slight wandering of a polarization angle. Instruments turn the invisible into guidance. The outskirts answer in numbers rather than vistas, but the numbers are reliable companions. With them, the route through a giant's breath becomes as charted as any lane along a spiral arm, and the notion of outside becomes a gradient of evidence rather than a distance on a map. Gravity tips the landscape until the horizon changes its allegiance. The pull that once pointed toward a single heart begins to lean toward a partner, glimmering 2.5 million light-years away. The traveler does not see a border. The shift is felt as a softness in one direction and a quiet insistence in another, a tilt in the invisible ground that guides trajectories toward a shared basin. In this basin, two spirals face one another across a thin wilderness. Their halos overlap in potential, long before their stars brush sleeves. The space between is not neutral. It is a valley cut into the cosmic plateau by the combined mass of neighbors that will one day meet. The geometry can be imagined as two hills inverted into wells. Near each well, local slopes carry test particles inward. Far from both, the universal expansion stretches space and pulls away. Somewhere in between lies a ridge where these tendencies balance. Cross the ridge and the downhill direction changes. The ridge is not crisp. It wavers with the orbits of satellites and the eddies of warm gas, yet the concept is firm. There exists a surface where expansion yields to a partnership of gravities. Inside it, motions no longer notice the general drift of galaxies. They fall toward the pair. In this shared gravity, the nearest companion to the remote spiral plays a third role. A smaller disk loops around the larger one like a swift bird around a tall tree, tugging the field into a delicate asymmetry. Its presence thickens the web of paths that lead through the basin and alters the timing of everything that will follow. The three bodies together route a swath of nearby space, gathering a community of dwarfs and clusters that attend their movement. Some satellites are faithful to one host, others wander along elongated orbits that bow to the group as a whole more than to any single member. The dark scaffolding that underlies each system broadens enough here that the two start to touch in influence. The steep inner parts of each halo remain distinct, but the outer slopes create a continuum. Those slopes catch outflows from both disks and herd them into lanes where pressure is lower. A corridor of tenuous gas extends along the line that joins the pair. Within that corridor, density is still low by human standards, and yet higher than in random void. Metals from each galaxy drift into the channel and add flavor to the broth. In its threads, atoms forged on one side may one day feed stars on the other. Satellites arrange themselves in patterns that reflect this larger architecture. Around one giant, a partial plane of companions seems to tilt toward the intergalactic direction, as if arrivals prefer approach lanes set by the connecting filament of the cosmic web. Around the other, streams and shells tilt likewise, some pointing roughly toward the neighbor that pulls with implacable patience. Not every satellite obeys. A few occupy high latitudes in the potential and prove that randomness retains a vote, yet the overall impression is one of guidance. The basin does not demand symmetry, but it encourages coherence over long durations. Motion in the basin is not quiet. Peculiar velocities add to or subtract from expansion depending on direction. Dwarfs that stray too near to the ridge find themselves returned, like leaves whipped back by a wind that changes with altitude. Those that have already fallen inside the group sway on long, looping courses, their orbits precessing under the three-body influence of central giants and their large companion. Over billions of years, such orbits might circularize or dive, depending on mass and friction with the warm background. The end states range from absorption into the larger disks to long life, as peripheral companions riding the turning of the whole. The medium between galaxies in this enclave achieves temperatures that make traditional pictures of vacuum seem naive. Electrons roam in a bath where collisions are rare but sufficient to smooth pressures across hundreds of thousands of light years. The background is ornamented by cooler clumps, adrift on lines where entropy is lower. Some clumps are the exhausted leftovers of earlier outflows. Others are new condensations born at the edges of mixing layers where warm and hot phases rub against one another. Gravity from the pair shapes the distribution, bending trajectories ever so slightly, so that clouds gather along the axis connecting the twins. A diffusion of radio-loud particles threads the same domain, guided by faint magnetic fields that lace the basin. Viewed from a distance, the two spirals approach with a relative motion that carries the promise of union. The pace is slow by human scales, yet quick by cosmological measures. The line of sight velocity is hopelessly modest, a mere punctuation in a long sentence, but the proper motion contains the real tale. A small sideways drift means the future will include a close passage. A larger drift means a glancing interaction that may delay the final embrace. The true path cannot be sketched with a straight ruler. It wobbles, influenced by the smaller third body and by the drag of hosts of dwarfs. Still, the vector points inward across the shared valley, and that is enough to grant the basin its name. Barycenters in such systems do not sit at the centers of light. They hang somewhere in the darkness between, a point where the moment arms of mass balance perfectly. If every star and every dark particle could be counted, a single position in space would be found where a small object could hover in a form of gravitational freefall relative to the pair. The traveler who slipped onto that point would feel the gentlest of tides, curving without falling toward either surface. Such points are more ideals than practical way stations, but they exist mathematically, and their drift through space over eons tells the story of how the group tightens. The history that led to this arrangement can be read in the deficit and excess of motion among the smallest members. Dwarfs on profitable tours around the giants carry scars of tides in their elongated shapes and in their stripped gas. Those farther out still carry gas and present as upright irregulars with ongoing star formation. Their distributions and spins reflect the path by which matter rained into the group from the larger web. Some also show hints of having been pre-processed in smaller associations before arrival. adding layers of memory to their current state. A crossing of this region invites recalibration of silence. True emptiness is rare. Even far from any disk, the background shines faintly in lines of excited oxygen and whispers in free electrons that bend passing radio waves. A craft that listens as it moves would tease out gradients in this faintness. Slight increases would betray approach toward the central line. Slight decreases would mark excursions toward the periphery. Fluctuations would reveal eddies stirred by old outbursts that inflated cavities tens of kiloparsecs across. On long baselines, the map that emerges is smooth, yet on small scales it is stippled by the signatures of flows and wakes. Around both giants, globular clusters with grand apocenters act as messengers between the inner and outer realms. Their orbits cut across the basin like slow comets of ancient stars. The procession of those paths is a litmus for the shape of the combined potential. If the basin were perfectly symmetric, the clusters would trace the same loops forever. They do not. Their apocenters shift in angle with each pass, leaving behind a tracer pattern that, when collected and decoded, sketches the slope and flatness of the group field. Clusters thus serve as compasses for navigators who cannot see the gravity they obey. Amid all this, the general expansion of the universe does not vanish. Beyond a certain distance from the combined mass, the Hubble flow resumes its authority. There, the tug from the pair cannot bind. Objects at that outer edge drift outward, faster than the group can retrieve them. This circumference is not precise, but maps of local motions find a radius where average peculiar velocities change sign. Inside that radius, the group is a country. Outside it, the river of expansion carries travelers away toward larger gatherings. The circumscribed country breathes, however, exchanging gas and even a few small systems with its surroundings through rare corridors. The idea of crossing here is less about a line and more about a sense. A traveler feels the ground fall away from the home spiral and rise toward the neighbor. Instruments confirm the turn by measuring tiny changes in acceleration over long times. The cosmic microwave background offers a compass of last resort. Against its near-perfect uniformity, the motion of the group imprints a dipole. By subtracting that motion, one enters the group frame, where the basin becomes at rest, and the internal choreography can be read without the blur of external drift. At a human scale, nothing in this region seems to move at all. On the scale of the systems involved, everything leans toward a rendezvous. Streams of dark matter intertwine, threads of gas stretch and snap, satellites choose allegiances by gradual degrees. The prospect of a future union shapes the present in subtle ways. Flows along the axis between the main bodies are easier. Outflows along poles find pathways into low-density cavities that point away from the line. These details accumulate into a bias that would eventually be noticed in the distribution of elements and in the kinematics of clouds. A ship coasting through this shared basin would not be compelled to choose sides. It could orbit the barycenter, map the corridor, taste the metallicity gradient, and measure the crosstalk between magnetized regions. It would eventually see the true sweep of both spirals grow larger in the same sky. It would watch the quick neighbor glide slowly in arc, spreading its disk into a broad oval. It would learn that a group is a form of community in gravity, where identities are kept but destinies are linked. The crossing is simply the point where that linking becomes undeniable to a mind trained by motion. Threads rise from the dark, like rivers caught in first light. They stitch galaxies into a continent that has no shore, meeting at crossroads where knots thicken and heat. The traveler enters this country and finds that space is not a blank between islands. It is a fabric pulled into filaments and loosened into voids, a topography of gravity written on a canvas of nearly nothing. Where the threads cross, matter condenses into swarms of stars and long-lived halos. Where the fabric relaxes, emptiness expands into caverns so wide that a single galaxy becomes a solitary bell hung in a hall of silence. The filaments carry memory of their birth. Long ago, small ripples in the early fireball grew until sheets formed, then sheets folded into strands. The mathematics is economical. Gravity amplifies contrast. Anisotropy focuses collapse. and the result is an architecture whose form is simple while its detail is intricate. Along each strand flows a slow commerce. Gas streams inward, dark matter glides with it. Galaxies ride the current like boats moving toward a harbour that always lies a little farther on. Shocks line the lanes where infalling gas meets hotter reservoirs at the knots. Temperatures jump, electrons rattle the microwave sea into tiny distortions. The road itself announces where it is. Within the strands, the gas cools by degrees. Some parcels drift at hundreds of thousands of kelvins, an intermediate regime that is too warm to shine brilliantly and too cool to light the X-ray sky. This warm, hot intergalactic medium is the quiet treasury of ordinary matter, a place where metals from countless supernovae have been salted into diffuse air. Other parcels are cooler, shielded by geometry and guided along creases where pressure is lower. They arrive at the boundaries of halos, still bearing the chemical accent of their route. When such parcels reach favorable gradients, they can feed disks with a grace that delays the need for violent accretion. Magnetism rides the filaments like threads within threads. Fields are stretched by shear and twisted by tides, then anchored by the slow churn of collapsing flows. Cosmic rays surf along these lines and help spread energy without adding much mass. The effect is subtle at any point, yet cumulative over long distances. Clouds that should have torn apart keep cohesion a little longer. Turbulence that should have erased a gradient lets it survive to become a corridor. Over time, the magnetized lanes learn to guide matter with a precision that belies their faintness. Galaxies respond to the roads beneath them. Spins are not random. Small systems tend to align their rotation axes with the strands they follow, as if torque were handed down by the same tides that sculpted the larger structure. More massive systems arrive later with different habits, their spins often flipping to sit perpendicular to the filament once they have grown fat within the nodes. This choreography is statistical, not absolute, but its imprint can be read in surveys that compare shape, motion, and environment. The road tells travelers how to turn, and many listen. Voids offer a different lesson. Inside their wide rooms, the expansion of space runs a little ahead of the average. Peculiar velocities aim outward, and walls do not form unless invited by distant tides. A galaxy living here evolves in a diet of scarcity. Gas arrives gently, star formation proceeds in modest tides, and interactions are rare enough to be notable. The absence of crowding becomes a kind of purity. Disks remain thin, bars take longer to grow, metallicity stays low in places where history has been quiet. The void is not empty, it is simply unhurried. Edges between strands and caverns form frontiers where change is quick by cosmic standards. At these boundaries, streams of gas can shear into thin veils that sparkle in ultraviolet when they are seen against distant lanterns. Density drops across small distances, and magnetic field lines flare outward, as if released from tension. Shock fronts ripple through the medium when a cluster at a node flares with a bout of infall or a burst of feedback. Over tens of millions of years, the ripples cross the lane and fade, leaving behind slight reheating and a reorganization of small clouds that will matter much later when they are invited into a halo. The traveler crossing a filament notices that gravity feels directional. The pull is stronger toward the thread's spine than toward its sides. In the spine, tidal forces stretch in one axis and compress in the other two, arranging orbits into elongated loops that point along the road. Dwarfs that fall into this geometry are tidally trimmed into needles before they are folded into larger systems. Their streams trace the lane as they dissolve, writing foreshadowings of future structure long before any merger completes. The effect is gentle but widespread, turning the web itself into a map that predicts where signatures of past meals are likely to be found. Light tells where the threads lie even when matter is faint. A distant quasar's spectrum carries a comb of narrow imprints as it passes through successive sheets of gas, each imprint at a slightly different redshift where another page of the web intervenes. The forest of lines looks chaotic to a hurried glance. To a patient reader, it is a set of stacked contour maps, each line a lake at a particular elevation in density and temperature. By comparing many such sightlines, a three-dimensional sketch of filaments appears, draped across the sky like the grain in a piece of aged wood. At the nodes, the cosmic rivers pile into deltas of gravity. Halos nest within halos. Satellites enter along preferred corridors and are sorted by mass, with the smaller ones arriving more frequently and the larger ones seldom but with lasting drama. Gas can be shock-heated to tens of millions of degrees at the deepest crossings, then cool along splintered seams where turbulence permits escape. The balance between heating and cooling sets the pace at which fresh material can reach star-forming disks. When heating wins, galaxies catch their breath. When cooling finds a path, star formation can surge in a season measured in hundreds of millions of years. The emptiness near the centers of voids is not entirely silent. A faint glow of ionized oxygen peels from the thin air. Fast radio pulses that happen to cross a void arrive with smaller delays than similar pulses that thread a filament, a difference measurable when many events are stacked. Polarization angles from distant radio sources rotate less through these caverns, hinting that magnetic fields here are softer and less tangled. These subtleties together outline the borders of the Great Hollows and confirm that their volumes are as large as maps suggest. Motion across the web has a hierarchy of timescales. Gas moves along a filament toward a node in a few billion years. Stars in galaxies ride those motions while busy with their shorter orbits. Dark matter drifts with the same sobriety as the gas, but does not radiate and therefore does not cool into narrow streams. The mismatch produces wakes and eddies where the luminous and the invisible part ways by small amounts. Streams of stars can feel these differences. Their paths acquire little jogs that, when interpreted correctly, turn into constraints on how matter shares lanes in this infrastructure. A navigator who wants to conserve fuel would let the web do the work. He would ride a gradient of potential toward a node, then slip sideways into the gentle slope of a neighboring filament. The path would look like a string of shallow S-curves on a map of the potential, each curve avoiding the costly climb out of a well by keeping to the saddle between depressions. Along the way, instruments would count electrons by how they delay radio pulses and sketch the pressure by how they distort the microwave sea. Metallicity would be sampled from thin absorption lines, charting where the breath of galaxies has flavored the road. The cosmic web is often drawn as a metaphor for neurons or rivers, but the likeness runs deeper than illustration. It is a transport network that balances supply and demand. It delivers gas to where it can condense and sends away energy in forms that prevent premature collapse. It stores history in the way threads twist and in how nodes fatten or slim with time. It also cultivates diversity. Galaxies raised within crowded interchanges grow differently from those raised in pastoral lanes or in far hollows. The landscape does not dictate fate, but it sets conditions that echo through every disk, bar, bulge, and halo. At scales wider than the web's repeating lattice, even the threads give way to a larger simplicity. Expansion reasserts its smoothness and erases local peculiarities into a calm that only the oldest background can register. Yet the imprint of the web remains in the slow motions of large associations and in the very slight slant of temperature against the oldest light. The universe, large beyond metaphor, carries the signature of these roads like the grain in an ancient beam that still holds a roof upright. The traveller pauses where a filament thins into the lip of a void. Stars are fewer, gas is clearer, the gravitational pull is nearly equal in all directions and yet somehow points outward by a whisper. The view is austere. Beauty lives in gradients, in the quiet curvature of potential, in the way a distant knot glows a little warmer in microwave maps. Beyond, another thread waits, tilted at an angle that suggests a path if patience is long enough. There is no border here, only choice shaped by terrain. The journey is a learning of roads, and the roads are made of faint matter guided by stronger ideas. Edges multiply when definitions are honest. A galaxy can be bounded by light, by mass, by temperature, by the fate of orbits, by the rate at which material forgets it belongs. Each measure draws a different contour on the same sky. The result is not contradiction, it is parallax. The outline shifts with the instrument and with the quantity being traced. A quiet truth emerges from this shifting. The end of a galaxy is a choice about what one wishes to keep. One school prefers energy as the arbiter. There exists a radius inside which typical matter is dynamically bound, where kinetic motions and gravitational potential settle into a state that can be called relaxed. This region is given a name tied to an overdensity threshold relative to the surrounding universe. The number is chosen to be convenient, so that structures compared across time share a consistent meaning. Call it the virial boundary. Inside it, velocities balance gravity's claim. Outside it, infall and outflow still argue. The boundary breathes with cosmic time. As the universe expands and matter thins, the same threshold encloses a changing physical size, even if the actual mass grows only modestly. The meaning is statistical, yet it guides intuition about where equilibria are likely. Another proposal listens to trajectories rather than to averages. As material falls toward a halo for the first time, it accelerates inward, then recoils at apocenter and creates a caustic, a gentle pileup where orbits turn. This turning surface appears in simulations as a steep drop in the number of traces or in their radial velocities. The surface is called splashback. It marks the first apocenter of newly accreted matter, a practical frontier between outside that has never been inside and inside that has begun to orbit. This frontier sits at a radius that changes with how quickly the system currently grows. Fast growth pushes the surface inward, slow growth lets it relax outward. The edge becomes a chronometer. It tells how greedily a halo has been eating. Observers build tests for both ideas. Galaxies are stacked by mass and environment to smooth away irregularities. Then the number density of small satellites is measured as a function of distance. A sharp steepening in that profile near a certain radius argues for the first apocenter. At the same time, weak lensing maps the projected mass and offers a complementary slope change that can be compared with the trace account. Neither method requires the galaxy to glow, they use gravity as ink. Where both see a bend, a boundary of a practical kind has been found, not a wall, but a ring of altered behavior. Light sketches a different limit when the metric is surface brightness. The luminous disk fades into a faint haze that eventually sinks below the night sky and into the noise of the detector. Isophotral radii define the contour where the light of the system equals a given level. The choice of level is arbitrary, yet useful for comparing similar galaxies. This edge measures the visible body rather than the gravitational reach. It ends early because stars are rare in the outskirts, not because the galaxy ceases. Between this photometric limit and the dynamical frontier lies a large space where the system remains influential though dark. Gas chooses its own borders. Temperature profiles reveal where hot phases that belong to a galaxy's breath mix into the more delicate plasma of the intergalactic medium. Pressure profiles show where electrons thin enough that their effect on the ancient microwave sea becomes hard to separate from background. Metallicity profiles reveal where the air carries the taste of recycled stardust, and where that taste fades into the blandness of untouched cosmic broth. These chemical contours can stretch far beyond the last counted stars. They place the end of enrichment at radii that move with time as winds rise and fall. Tides pull at every definition. In a group or cluster, the effective reach of a galaxy is set by a balance between its own mass and the larger sea that surrounds it. A tidal radius can be defined where orbits around the smaller system begin to feel unstable because of the larger one's gradient. Inside this radius, satellites can remain attached to the lesser host. Outside it, they are free to be captured by the group. Such a measure creates an edge that is not spherically symmetric and not fixed. It stretches toward the group center and recedes away from it, warping into a teardrop that shifts with orbit phase. In that teardrop, identity is conditional. Stars act as obedient traces of some borders and indifferent witnesses to others. Globular clusters with long orbits fly far beyond photometric edges and return with information about mass profiles that light alone could not predict. Streams outline equipotentials and reveal where the field changes shape. Yet stars do not always go where gas goes. They ignore pressure and conduction. They speak the language of gravity, and only that. When edges are drawn using stellar kinematics, the result is a coarse sketch of mass and nothing more. When edges are drawn using gas, The result is a sketch of circulation and thermodynamics. To confuse these is to misread the map. There are definitions born of convenience that have proven durable. A radius enclosing a mass that is 200 times the critical density yields a measure that is simple to compare across systems. Substitute the mean density of the universe for the critical one, and the number is different, yet equally consistent within itself. These conventions make catalogues easy to read. They do not pretend to enact a physical law. They are rulers set on a desk, where the object sprawls beyond the desk. Used with care, they reveal trends. Used without care, they hide nuance inside tidy columns. Phase space boundaries offer another perspective. Plot each tracer by position and velocity, and patterns appear that separate infall from splashback from virialized motion. The borders in this diagram are more precise than any border in real space. They show transitions in behavior that remain clear even when geometry is messy. The edges are given by gaps in allowed energies, or by shifts in the shape of the distribution function. Observers approach these constructs cautiously, because velocities are hard to measure in 3 dimensions and distances have their uncertainties. Yet the method has the virtue of aiming at first principles rather than at proxies. Edges can be drawn by time as well. Consider how long a parcel of gas requires to cool compared with how long gravity requires to move it across a characteristic distance. Where cooling times are short, condensation can proceed and clouds survive. Where cooling times are long, heat prevails and clouds evaporate. A radius where these times cross becomes a useful threshold for predicting where cold streams might reach, where warm interfaces will dominate, and where a hot, pressure-supported atmosphere sets the tone. This threshold depends on metallicity, on turbulence, on the history of heating from vigorous star formation or from a central engine. It is therefore personal to each galaxy. Edges also follow entropy. Gas with low entropy is more likely to condense and rain. Gas with high entropy is stubborn and resists collapse. Profiles of entropy rise outward as a rule, but bumps and shelves appear where past outflows inflated cavities or where fresh infall introduced cooler material. A contour of constant entropy does not mark a border, but changes in slope identify zones. In these zones, the circulation pattern switches from fountain-dominated to infall-dominated, from cooling-led to heating-led, from clumpy to smooth. A traveler sensitive to such signals would know which region he has entered without seeing a single star. Machine learning introduces a pragmatic edge that is neither classical nor arbitrary. Algorithms trained on simulations can take observables such as satellite counts, surface brightness profiles, gas line strengths, and lensing maps, and infer a radius beyond which additional information adds little to the prediction of global properties. The model draws a boundary that optimizes knowledge gain. It is an engineering edge rather than a physical one. It says here is where classification saturates, here is where extra effort yields diminishing return. Such edges guide survey design as surely as more traditional borders guide theory. When thinkers argue for one definition over another, the stakes are not trivial. The chosen edge affects estimates of total mass and baryon fraction, of star formation efficiency, of how far metals reach, of where satellites become exiles. It influences how feedback is tuned in simulations and how growth histories are reconstructed from present-day profiles. It shapes predictions for how many fast stars should exist and how easily a small system can be stripped of its gas. The choice propagates through the grammar of explanation. A reconciled view treats edges as a layered set. The luminous body ends where light fades into the night. The bound body ends where energy balance gives way to ongoing infall. The recently accreted body ends at the first apocenter caustic. The chemical body ends where metallicity declines to the level of the field between galaxies. The tidal body ends where the group's gradient interrupts loyalty. The practical body ends where measurements cease to change what is believed about the whole. Depending on purpose, one or another of these will be the correct answer, never the only answer. In the quiet of calculation, a simple sentence holds the complexity together. A galaxy is a region where gravity, gas, and time organize themselves into a long living pattern. The frontier of that pattern is not a curb, but a set of gradients. Each gradient invites a different kind of question. Where does equilibrium hold? Where do orbits turn first? Where does heat surrender? Where does loyalty to a larger structure begin? Where does more observation stop changing the story? The edges are many because the questions are many. The map becomes a stack of semi-transparent sheets, each true within its frame, each incomplete alone. A traveler who seeks a single line will be disappointed. A traveler who accepts layered borders will find that navigation becomes easier, not harder. Light will tell when the city thins. Orbits will tell when the town limits end. Chemistry will tell when the language changes. Tides will tell when jurisdiction shifts. Entropy will tell when weather patterns switch. Together, these signs compose a frontier that is faithful to nature's habit of refusing simplicity that has not been earned. The edge is unfixed because the galaxy is not a thing but an ongoing relation. The boundary is a moving conversation between mass, motion, and memory. Instruments gather at the frontier like lanterns along a foggy coast. Each aims a different light into the thin regions where definitions blur. Together they turn gradients into contours and conjectures into measurable weather. The portrait begins with astrometry. A satellite that measures angles with micro-arcsecond poise turns the sky into a grid where stars no longer drift anonymously. Proper motions and parallaxes deliver six-dimensional maps for millions of tracers. With those coordinates, faint rivers of stars are straightened in action space, globular clusters reveal apocenters like breath marks, and the tilt of the gravitational field becomes a number rather than a hunch. Substructures that once hid inside noise step forward as named actors. Their motions tie mass to shape and let dynamical models trade allegory for arithmetic. Photometry adds the timekeeper. Variable stars flicker with periods that encode luminosity, and from luminosity comes distance. RR Lyrae and Cepheids seed a scaffolding on which the outskirts can be hung in depth rather than drawn as a flat veil. Tip of the red giant branch methods extend that scaffold to even fainter populations. The result is a ladder capable of reaching the halo and tasting its thickness. When those distances are married to velocities, orbits can be solved, and when orbits are solved, the potential can be inferred. The equation that relates position and speed to mass ceases to be an abstract principle and becomes a set of fitted parameters with uncertainties that can be made smaller by building better telescopes. Spectrographs act as interrogators. Each line carries a temperature, a density, a composition, a velocity shift. Multi-object instruments on wide-field telescopes collect spectra for thousands of stars in a single pointing. Out of such harvests fall metallicity maps that label family lines among halo stars, revealing who was born in situ and who arrived as a guest. Abundance ratios expose the tempo of star formation in long-digested dwarfs versus the larger host. Velocity dispersions across streams calibrate the roughness of the potential. If a stream is colder than expected, the field must be smoother. If it is hotter or shows gaps, unseen clumps have passed through. The spectrograph therefore becomes a stethoscope for a patient the size of a galaxy. Ultraviolet instruments peer past the stars to listen for gas. Against the bright continua of remote beacons, absorption lines reveal ionized matter sprawled in layers far beyond the last visible suns. Column densities as a function of impact parameter sketch how the atmosphere thins. Ion ratios sort temperatures and pressures, covering fractions weigh ubiquity. The data can be assembled into tomographic slices that show how metal-rich fountains and more primitive inflows braid into a single reservoir. The same method reveals where cooling has succeeded in condensing knots, and where turbulence and conduction keep clouds from forming. X-rays take the temperature of the hottest phase. Imaging detects faint glows around massive disks, while high-resolution spectroscopy separates lines of highly ionized oxygen and iron that whisper of densities and bulk flows. Calorimeters with fine energy response resolve turbulent widths that would otherwise masquerade as multiple components. When those widths are small, the medium is quiescent. When large, the medium has been recently stirred. Bubbles carved by ancient outbursts show up as edges. Their sizes and pressures become caloric records that date the storms that formed them. Microwave observatories exploit a background that fills all directions. Hot electrons in the outskirts steal a pinch of energy from ancient photons, imprinting a thermal shadow whose amplitude measures pressure integrated along the line of sight. The signature is gentle around single galaxies, yet stacking thousands of systems brings it above the noise. The pattern traces where halos carry overweight atmospheres and where feedback has thinned them. A subtler kinematic variant measures bulk motion and sketches inflow and outflow lanes statistically. This method replaces a missing image with an honest integral and demonstrates that pressure belongs to the same cartographic canon as light and mass. Radio arrays reach for structure that other bands miss. Neutral hydrogen at 21 centimeters paints filaments, clouds, and long ribbons peeled from companions. Spectral cubes show velocity as color, letting ram pressure and tides be distinguished by how the gas is stretched. At lower frequencies, synchrotron maps reveal where cosmic rays and magnetic fields cohabitate. Polarization angles rotate as waves pass through magnetized plasma, and from the rotation measure, one can infer the product of electron density and field strength integrated along the line of sight. A net of background radio sources with measured rotations turns the halo into a Faraday screen that can be peeled layer by layer with enough sightlines. Such screens explain the survival of cool clumps and the preferred corridors for wind. Fast radio pulses add an elegant clock. Each millisecond flash arrives with low frequencies delayed more than high, and the delay is proportional to the number of electrons encountered. By cataloguing many pulses across the sky and subtracting contributions from local media and the intergalactic mean, one isolates the electrons that belong to halos. With localization refined to arc-second scales, the dispersion can be tied to a specific line of sight through a specific system. Over time, the growing archive becomes a census of electron content as a function of radius and host type, a direct probe of the ordinary matter that has been so elusive in other forms. Gravitational lensing observes nothing but bending. It measures mass without prejudice to whether that mass shines or glows. In the weak regime, the shapes of distant galaxies are subtly distorted by the foreground field. Statistically, those distortions map projected mass in broad strokes. Around individual systems, the signal is faint, yet averaged over many analogues it yields a radial profile that can be compared with dynamical inferences. Changes in slope hint at transitions from inner dominance to outer scaffolding. Small deviations from smoothness betray substructure. Cross-correlating lensing maps with the positions of streams and satellites turns cosseted theory into a cross-checked inventory. Time domain surveys make the outskirts audible to cadence. Transients that occur along the line of sight offer backlights that can be caught if instruments are quick. Afterglows brighten and fade, and during the bright window, a spectrograph can sample the halo of a nearer system with exquisite signal. Repeat events provide multiple passes through the same parcel of plasma, constraining change. Long baseline astrometry reveals minuscule accelerations of tracers that pass through weak gradients, turning featureless expanses into slopes measurable by persistence. With patience, proper motion maps begin to show the very slow breathing of the outskirts as orbits precess and as the bulk potential tilts under the influence of companions. Computation keeps pace with observation. Cosmological simulations evolve dark and luminous matter together and produce mock skies where every star knows its ancestry and every cloud knows its temperature. Synthetic observations are made by painting dust into ionized volumes, by ray tracing through hot gas to predict absorption-equivalent widths, by tracking stellar debris from satellites to build artificial streams whose kinematics can be compared directly to what telescopes see. Agreement is celebrated cautiously. Disagreement becomes a lamp that points to missing physics, perhaps in how feedback heats, how conduction smooths, or how magnetic fields brace clouds. Machine learning acts as a bilingual translator between catalog and cause. Algorithms trained on simulated universes learn to connect patterns in data to underlying parameters that would be hard to derive by hand. Give the model a field of satellite positions, a handful of stream curvatures, a lensing slope, and a set of gas line strengths, and it returns a posterior over halo concentration, shape, and mass growth rate. The translation is not magic. It requires a training set that spans reality and a validation loop that punishes glib guesses. When used humbly, the result is a set of priors that direct expensive follow-up to where it matters. New instruments sharpen the next questions. An optical infrared surveyor with a broad camera will trace weak lensing over such vast areas that halo shapes can be stacked by environment. A ground-based observatory with a gargantuan mirror and quick cadence will harvest streams and variables to the edge of detectability. A European mapper of geometry will measure cosmic shear in a way that calibrates mass in the outskirts without relying on any one model. A next-generation X-ray mission will resolve lines in hot halos cleanly enough to separate turbulence from bulk flow. A square kilometer of radio collecting area will turn Faraday rotation into a dense lattice of measurements and will detect neutral hydrogen that now lies below the floor. A next-generation centimeter array will unveil cold gas filaments at the brink of halos and show how they connect to the warm phases sensed in other bands. The suite forms a choir. Each voice corrects the others. Across all these efforts runs the insistence on standards. Distances are reconciled through cross-calibration between time-honored candles and geometric anchors. Metallicity scales are harmonized so that surveys do not speak dialects that confuse comparison. Selection functions are measured rather than guessed, so that absence in a catalogue is not mistaken for absence in the sky. Statistical frameworks track uncertainty and propagate it forward, keeping error bars honest when interpretations are made bold. The frontier can be poetic, but the accounting behind it is rigorous. Testing does not end with a finished map. Hypotheses about the nature of the unseen majority remain in play. Counts of stream gaps constrain how grainy the dark scaffolding is. Cores or cusps in dwarfs test heat exchange between stars and halo. The precession of long streams tests triaxial shapes that simulations predict. Correlations between gas temperature and star formation history test how feedback seeds the atmosphere with energy. Each test is an experiment conducted by the universe and read by patient minds. Failures are as informative as successes. They prune families of models and keep the narrative from drifting into fantasy. A traveler equipped with this arsenal would steer by numbers as readily as by stars. He would plot a course through gradients of pressure rather than through constellations, thread corridors where rotation measures are low, and avoid eddies hinted at by broadened X-ray lines. He would trust that a small change in the shape of a stream's phase space track portends an unseen perturbation ahead. He would keep to lanes where the microwave sea is least disturbed, saving propulsion for the long arcs. The tools would be the map as much as any picture, and the moving frontier would be followed not by crossing a line, but by keeping up with the measurements that define what a line could mean. Risk begins as a whisper in the hull. It is the arithmetic of thinness set against time, the certainty that every kilometer from a star is a quiet subtraction from warmth, signal, and shelter. Out where orbits loosen into long chords and the sky thins to scattered jewels, a traveler inherits the hazards that stars once softened. The first is radiation. Charged particles arrive with the force of stray thoughts, but the consequence of chisels. Protons from old supernovae and heavy ions accelerated by ancient shocks cross the dark with energies that ignore reluctance. They flip bits in memory, scar molecules, and stitch latent fractures in living tissue. Their spectrum is a biography of the galaxy's violence written in invisible ink. Shielding stops some of it. Water is kind and multi-purpose. Hydrogen rich and forgiving. Magnetic fields built into the bones of a craft can turn away lighter particles and blur the trajectories of heavier ones. Yet no barrier is perfect. Over years, the uninvited accumulate. Electronics cope with redundancy and error correction. Biology copes with repair or with sleep deeper than sleep, its risks measured by statistics and time. The second hazard is smallness moving fast. Dust no larger than a grain of sand becomes an event at a fraction of light speed. Impact melts into plasma in a breathless instant. Whipple shields turn the single blow into a spray that a second skin can swallow. Angled, sacrificial panels convince momentum to spend itself in detours. Still, the ledger must be kept. Every hit adds heat, adds pitting, adds a soft fog to optics that once were sharp. On a sail, the risk is worse. A perforation becomes a logic puzzle for stress. Edges curl, tension redistributes. The sail survives until it does not. Metal foils and metamaterials promise better odds, but no promise removes the need for repairs that must be imagined before the first tear exists. Environment becomes the third risk, where there is almost none. Thermal control turns perverse in a country without sunshine. Near a star, the problem is shedding heat. Far from any hearth, the problem is making it and keeping it. Radiators must pivot from being brakes to being lungs, exhaling the slow fever of reactors while conserving what little warmth the crew and instruments require. Each square meter of radiator invited to release heat is also an invitation to micrometeoroids. Self-sealing channels and capillary loops practice the art of local failure that does not become global. The fourth hazard is famine. Power fades with distance from starlight and with age in all finite stores. An isotope box glows steadily for decades, then for half-centuries, then for centuries only if engineered with optimism. Fission asks for mass and moderation. Fusion asks for confinement that laughs at impatience. Beamed energy demands alignment and friends who never forget to aim. One by one, easy options thin. The traveler learns to drink from weak wells. Waste heat is harvested across narrower gaps. Sleep cycles are lengthened. Instruments share clocks like misers sharing candles. What used to be continuous becomes pulsed. What used to be luxury becomes rhythm. Even software learns to wait. The fifth is time itself. Communication stretches until conversation becomes archive. Hours become days, then years, then the near silence of one-way messages whose replies will be read by people not yet born or by no one at all. Autonomy turns from convenience into the only ethic that keeps the mission honest. A craft must choose. It must reprioritize when detectors age out, when a subsystem dies, when the sky offers a surprise window through a rare alignment. The risk is not only wrong choices, it is brittle certainty. The antidote is a faculty for revision written into code, a habit of arguing with one's own priors and recording that argument where future subroutines can find it. In such self-government, failure will still happen, but folly can be kept from becoming doctrine. Navigation seems trivial until stars thin. Near the disk, a tracker can triangulate on a feast of points. In the outskirts, the feast becomes a sparse table. Pulsars become the reliable anchors. Their ticks split darkness with metronomic grace. Yet dispersion and faintness nibble at the margins. Gyros drift. Cold creeps into bearings and turns saccade into smear. The craft learns to combine everything. Quasar spectra provide fixed backlights for attitude. The microwave sea offers a dipole that checks system motion. Gravity itself whispers through tiny accelerations integrated over months. The risk is not losing the road. The risk is believing that a line is straight when it has curved a little for a very long time. Materials age as slowly as the voyage. Plastics embrittle under ultraviolet needles. Metals creep where they should not. Solder joints crystallize, then crack in quiet, sub-audible ways. Lubricants migrate. Outgassing robs seals of their softness. Each of these facts is a chapter that ends not with a catastrophe but with a slow decline. The cure is not heroics, it is attrition by planning. Spare parts must be seeds rather than duplicates. Self-healing polymers must flow the way vascular systems do. Robots must be both surgeons and carpenters, trained on a library of failures never actually seen. When they cannot replace, they must reroute. When they cannot reroute, they must downgrade gracefully and publish their own elegies in data. Biology carries its private weather. Bones yield to the politeness of zero-G unless coaxed by resistance. Fluids reassess allegiance. Microbes adapt faster than schedules expect. Sleep loses its rhythm without sunrise and sunset. Minds widen or narrow depending on whether silence is friend or famine. Psychology becomes engineering. Cycles are enforced by light that is not the Sunday. Gardens are tended with the tenderness of monasteries whose purpose is not food but sanity. If the crew is replaced by processors, a different psychology arises. Machine attention is tireless and also fragile. Models overfit. Curiosity decays into loops that conserve energy but also shrink horizons. Preventing both forms of fatigue is part of navigation. Ethics follows close behind. A craft that can sample must decide what it may touch. Clouds of gas are not sacred, yet contamination has a direction and a scale. Seeds of biology should not be scattered like casual ash. If autonomous devices are allowed to copy themselves, rules must be strict enough to prevent a grey frontier of rake-like probes from ploughing everything into supply. The conservative choice is to decline replication and to accept a rate of discovery that matches patience. The brave choice is to permit growth within quotas and to bind the act to a covenant of reporting and restraint. The worst choice is to pretend the question does not exist. Hazards come disguised as cleverness. A Bussard scoop drinks hydrogen from the medium and feeds a fusion heart only as long as the drag from the scoop's field does not exceed the thrust it buys. In thin air, the math is unforgiving. Harvesting becomes braking. A sail that lived on a beam may find no graceful way to slow if no receiver waits at the far end. Momentum is easy to borrow from light when home is bright. Paying it back where the nearest star is a chilly spark requires architecture that must be in place before the journey begins. The thief of the future is improvisation born too late. Gravitation gives both hazard and hospitality. Ploughing too near a compact object is a lesson in geometry's sternness. Tidal gradients do not negotiate, yet most of the hazard field is empty of sharp teeth. The real risk comes from the passenger lists carried along. A large companion can wake the dark sea and drag a wake into which small craft stumble unprepared. Paths designed with a model of a smooth potential must be amended to include the folds and ripples that real halos carry. Streams of stars forewarn those folds if their kinks are read like weather maps. Information itself can thin like air. Over centuries, formats go stale. Error-correcting codes survive bit flips, then suffer bit rot as storage media age. Redundancy must be multimodal. Magnetic with optical, with geometric checksums written into the pattern of a scaffold that can be read by simple minds, should complex ones fail. Documentation must be both terse and encyclopedic. A manual that teaches first principles alongside procedures has a chance to be useful to a mind rebuilt in a future dialect. The risk here is not loss of data, it is loss of meaning. A picture without a legend can survive. It cannot teach. Resources in the void are rare, and yet not zero. Neutral hydrogen accumulates in slow drifts. Dust collects near old streams. Weak magnetic fields carry order that can be stored as low-grade energy or as alignment for sails. A careful traveller can take small tithes without losing speed. Cold is a reservoir and a trap. It permits superconductivity that makes some feats easy, then punishes any lapse with quenches that crack. Every advantage has a hidden edge. Knowing where it hides is part of the craft. The largest risk is seduction by triumph. A mission that reaches the frontier may be tempted to declare that the rest is extrapolation. It is not. Past the galaxy's weather, the grammar of scarcity becomes the only language spoken. Beacons are fewer. Help is none. Every correction burns not only fuel but future options. The wise course is to design the journey as a sequence of acceptable failures and to treat success as a surprise that does not change the budget. That posture leaves room for grace. He moves through a night where all these hazards are present and none allowed. The hull clicks occasionally, the dosimeter ticks like rain against a tent. Radiators glow in colors the eye cannot see. On the displays, pulsar ticks thread across long baselines and add into a line straight enough to trust for one more course update. The fuel gauge declines in digits that seem reluctant. The craft adapts small habits. It sleeps more. It communicates in bursts, then listens for echoes that are schedules rather than conversations. The risks keep their covenant. They are cumulative, not dramatic. They offer an honest bargain. Bring patience. Spend carefully. Do not mistake the desert for emptiness. Even the quiet can break things. At the far end of prudence lies courage. Not spectacle, not bravado, just the steady choice to continue when continuation demands humility and a precise mercy toward future time. That is the only way a small artifact can endure the long famine between stars and still have enough to weigh the breath of a galaxy and the hush that follows it. The hazards are many. The road is slow. The reward is a view in which a spiral of light hangs complete in one glance, its edges softened into gradients that no city light could teach. Risk is the price of that sight, paid in tiny coins over distances that turn days into chronicles. The paymaster is unromantic. The traveller, if careful, remains solvent. Becoming intergalactic happens softly. There is no ribbon to break, no gatekeeper to sign the log. It begins as a noticing that the background is steadier than any single star. That motion now is measured against a sea older than every orbit. The craft tunes its instruments and finds that the ancient light has become the smoothest compass. A dipole in the microwave glow whispers the speed of the traveller relative to the oldest frame available. Adjust for this tilt, and the universe is suddenly quiet. The line between neighbourhood and world gives way to a hush, in which distance itself is the main weather. In this realm, a different arithmetic takes charge. Velocities are small compared to light, yet expansion is not a rumour. The Hubble flow is no gale in a small basin, but it is a persistent drift that turns separations into sentences with futures. The equations that once spoke of bound orbits now give room to clocks that diverge cleanly. Minutes and hours keep their local honesty, yet the sightlines lengthen into years and decades before the smallest change registers. Redshift becomes a unit in the vocabulary. Photons arrive stretched, their colours shifted toward patience. Time is painted into every spectrum. The air between galaxies is not air in any familiar sense. Hydrogen hides at densities that would insult a laboratory vacuum, scattered like rare punctuation across a nearly blank page. Yet the page is not empty. Threads of warm plasma trace, invisible lanes, and faint magnetic fields stitch them together into a fabric that resists utter chaos. The fields are weak by terrestrial standards, yet they are steady, and their lines remember their origin in the slow stretch of structure across billions of years. Cosmic rays stroll along those threads with an indifference that is neither lazy nor hurried. They furnish a pressure that has no mass, and yet changes where clouds can condense. Light now has room to perform its full repertoire. Lensing bends distant galaxies into crescents and rings if a mass knot happens to lie along the path. Surface brightness dims with the square of distance, and with expansion besides, so every image wears a veil. The veil can be lifted by time rather than by power. Stack exposures across months, then years, and a halo around a far system emerges like chalk dust blown across writing. In that chalk dust, intergalactic stars reveal themselves as an unbound diaspora. They moved out during tides and collisions, and now they travel alone, emissaries without a flag. Their existence proves that belonging is sometimes a matter of path rather than address. Navigation becomes a practice in listening to the most durable clocks. Pulsars still tick, but their distribution is thin, and their beams are not aimed with courtesy. The microwave background keeps perfect time without landmarks. It serves as a metronome that never falters. A craft can measure the small drift in its own motion relative to that light, and use the drift to refine a long arc to a neighbouring thread. Even the slow change in redshift of a distant beacon becomes, in principle, a guide. Record a precise spectrum now, record another far later, and the tiny difference is the footstep of expansion itself. The universe reveals its gate directly then, not through models, but through the patience of repetition. Identity for matter evolves here. A star that leaves a galaxy is not less a star. It burns with the same physics and dies with the same choices, yet it sheds the obligations of a neighbourhood. Without a crowd to scatter its light, its solitude is clarifying. The same is true for a mind that travels far. It is not emptied by distance, it is exposed to scales that pry metaphors loose from their moorings. Home becomes less a place than a set of boundary conditions written into memory. Belonging becomes a function of which gradients are felt most strongly, and which are now too gentle to sway a course. The intergalactic medium is more than warmth and silence. It is a ledger of every exchange undertaken by every city of stars. Metals are spread thinly across it, hardly measurable in any one patch, yet unmistakable across the whole. They came from winds and outbursts, carried outward by the same physical patience that now carries a small craft. Their distribution tells stories of epochs when galaxies were rowdy, and of later epochs when they quieted and allowed their atmospheres to cool in place. The ratio of oxygen to neon to iron whispers about which kinds of detonations were more common, which kind of stars were more generous. A traveller with a spectrograph and time can read this ledger and know the biographies of places never visited. Gravity remains the author of large structures, but its sentences lengthen into paragraphs here. The pull toward any one mass is a suggestion at best, unless the traveller aims very nearby. The main sensation is the curvature of a vast page. Crawl toward a node, and the lines bend subtly inward, float toward a void, and they soften outward. It takes patience to prove either case, yet the proof exists in measured accelerations that, integrated over months, amount to less than a leaf falling in still air. Such is the delicacy of intergalactic navigation. The map is written in second derivatives and read with instruments that never blink. Memory acquires new units when the nearest lamp is a whole galaxy. The time it takes for a signal to complete a question and answer begins to look like the time it takes for a star to finish a middle age. Autonomy grows again, not as a rebellion but as a courtesy to those who cannot wait for every choice. The craft becomes its own steward and historian. It trims its course with whispers of thrust. It updates its models of foreground dust and background radiation for no other reason than to keep honesty alive. Honesty becomes the central engineering value, because lies about uncertainty multiply with distance until they consume the mission. The idea of rest is revised. Rest used to mean a parking orbit or a stable halo around a familiar axis. Here, rest means coasting in the frame, where the ancient light looks most even. It is a rest against a background rather than against a body. The craft can feel the moment when it has cancelled every small velocity except that granted by the slow-running fabric of space. The feeling is not a sensation in the hull, it is a reduction in bookkeeping. One term in the navigation equations goes to zero and does not come back. In such rest, the count of photons from all directions stabilizes into a symmetry that can be trusted. That symmetry is the closest this realm offers to a hearth. Sound never carries. Conversation is electromagnetic and memory. Yet the silence is not sterile. It is textured by distance and by the steady sift of background photons. In that texture, the mind near a window may choose to measure or to simply watch. Measurement produces tables and confidence intervals and a clarity about the rate at which voids become larger. Watching produces something more elusive, a respect for how structure persists at all in a universe devoted to evening out. It is this respect that makes the word intergalactic feel less like a boast and more like an admission of scale. Philosophy finds itself tempted to grow large in spaces like this. It notices that the grammar of edges has been replaced by the grammar of gradients. It notices that the object of study is no longer an object but a relationship among flows that unroll over distances hard to pronounce. It notices that loneliness is a misunderstanding of statistics. The density is low, not zero. Companionship exists as a curve rather than as a neighbor. To accept these lessons is to become what the word citizen means at this scale, not owner, not master. Participant in a pattern that needs no witness and yet is willing to be witnessed. There are sparse signs of craft that never required witnesses. Stars torn from their cities mark old corridors. Intracluster light drapes like a shawl around gatherings far denser than this quiet lane. On much larger stages, jets from central engines in massive systems carve cavities large enough to hold minor galaxies, a violence slow enough to look like sculpture. These signs are distant, but their logic is the same that once governed a room of bright spirals. Energy follows gradients, matter follows potential, memory follows both. The traveller's path now follows memory most of all, because the present is too thin to shout. It whispers and expects a listener taught by history. Practicality remains. Sails need trim, reactors need care. Radiators must keep their balance between loss and retention. The old hazards are not abolished by a change in address. Yet the scale of purpose smooths them into routine. To cross between cities and then beyond is to turn maintenance into liturgy, repeated because it keeps meaning available. Meaning, here is not found by arrival at a monument. It is found by the moment when a whole galaxy fits in a single instrument field, by the realization that its outline is softened by the very medium that enabled the crossing, by the knowledge that the same softening extends in all directions. He becomes intergalactic, not by winning a race, but by changing the reference frame of his thought. He learns to call the microwave sea home for purposes of calculation. He learns to read the small differences in dispersion that tell where electrons hide. He learns to value a tenth of a microkelvin as a letter from the countryside. He learns to write reports that may be read by beings who will never meet his launch site and yet will see the same background. The transformation is neither mystical nor trivial. It is the natural result of paying attention long enough for the largest structures to come into focus. There will be a moment when a particular spiral hangs in the window as a complete object. Arms turn with stately grace. A bar spans the center. The halo is invisible and felt. The surrounding threads show themselves in gentle pressure shadows in the old light. The craft takes a photograph that is really a stack of thousands of nights. The image is a promise that the universe still keeps. Across the dark, shape persists and invites new shapes. To stand in that invitation is what becoming intergalactic means. Not departure as escape, but arrival into a larger grammar where every sentence is written with more room between the words. From a good distance, the spiral looks like a kept promise. It is not the blinding ceiling that once washed the night with milk. It is a complete figure balanced on darkness, a slow whirlpool of starlight suspended in a bowl of its own gravity. Arms unfurl with the composure of tides. The central bar holds like a quiet bridge. The disc is translucent at the edges, stitched with faint knots where clusters gather and drift. Beyond the disc, the eye learns to sense absence as presence. A hem of nothing visible surrounds the whole, yet the shape of orbits says otherwise. The unseen halo is a gentle geometry that makes the visible possible, the way a windless day makes reflections faithful. Reflection is the first gift of distance. Seen entire, the spiral does not compete for attention with nearer lamps. It writes its own sentence from capital to period in one glance. The sentence is long, with commas shaped like star-forming regions and clauses stitched by dust. The grammar is gravity and feedback, the quiet push and pull that lets gas ignite and then restrains it, that winds arms without tearing them, that whispers to the bar when to buckle and when to hold. Reading this sentence from the outside grants a new literacy. The mind recognizes words it knew only as syllables before, and in that recognition understands that it once lived inside a single paragraph, believing it to be a book. Color shifts with altitude above memory. The inner lanes glow warm where old stars congregate. The arms show patches of blue where gas has chosen to return to brightness. Between them, dust writes in negative, tracing where light will one day emerge after the patient work of collapse. In the outskirts, the palette fades into the dim reds of elders and the soft grey of unresolved crowds. Even here, scattered lighthouses speak. Globular clusters hang like lanterns on antique hooks, each with a metallic accent that hints at where it grew up. Their orbits arch outward and back, hinting at a cradle larger than any single orbit. Motion completes the mirror. A careful count of the swirl reveals an almost musical timing. The pattern speed sits between the hurried beats of star formation and the unhurried measures of halo precession. Resonances appear where gas piles into lines that later bloom into arms. Bars exchange angular momentum with the disk and with the invisible sea. The whole turns as if respecting unwritten decorum, each component yielding a measure of energy when another needs to grow, then reclaiming it when the exchange has matured. Nowhere is there a conductor. The score is in the physics, and the orchestra plays it because it cannot do otherwise. The mirror also shows imperfection, and in that imperfection meaning gathers. Arms are not symmetric. A spur departs early on one side. A plume of faint stars traces a past encounter that has long faded from the loud registers. A slim stream crosses the halo like a line of handwriting on an old letter. These details prevent the spiral from being a diagram. They make it a biography. The biography does not dwell on scandals. It prefers quiet admissions written in tilt angles and metallicity gradients. Anyone who has studied the outskirts will see the confessions. The halo remembers meals. The disc remembers growth spurts. The bar remembers a season of rearrangement when talk spoke and the inner regions listened. Every mirror tests the viewer as much as the viewed. A mind that sees a whole galaxy properly must accept scales as moral instruction. Patience becomes not only a virtue, but a requirement of understanding. A single revolution of the outer disk takes longer than recorded history. A single calm in the central regions may last through many such revolutions. Yet this slowness contains invention. Outflows recede and later seed rain. Dwarfs are trimmed into rivers that later guide new stars. Nothing here is stalled. Everything is in motion, at a speed appropriate to its sentence. The darkness around the spiral is not disdain. It is permission. In permission, relationships are allowed to become themselves. A thin arch of gas reaches toward an older neighbor and carries metals like gossip that will become instruction in another city of stars. A knot of hot plasma holds shape far beyond expectation because a magnetic skin remembers how to keep the pressure fair. Even the void nearby performs a service. By not interfering, it gives the spiral room to be a spiral instead of a knot. The mirror reveals these courtesies plainly. Isolation is not loneliness. It is structure held clear of crowding. Identity is recast by the view. The galaxy is not the center of anything but its own obligations. It hosts, recycles, and returns. It does not reign. Its light, rich as it is, marks only a fraction of its presence. Its breath is larger than its face. Its history extends beyond its rim through the streams of adopted stars. It is a citizen of threads that are themselves citizens of a web that is itself a habit of the universe to grow complexity from the simplest rules available. To perceive this is to be humbled, not shrunken. Humility here is not smallness imposed by a vastness. It is a realization that participation is the only noble role available at any scale. The mirror is also a promise. On the far side of history, this spiral will merge with another and become a different geometry. Bars will dissolve and reform. Arms will lose their neatness and find new paths. The halo will inherit a different tilt and a different concentration. Most of its stars will continue their slow orbits, unbothered by the headline. The promise is not decay, it is continuance without nostalgia. The mirror lets that promise be contemplated without alarm. Structures persist not because they resist change, but because they change with manners. A traveler who has come far enough to hold this image must decide what the image asks. It asks for gentleness in inference. The tides that define a life do not announce themselves in any single snapshot. It asks for gratitude that thin gas and invisible matter can together sustain such an extended choreography. It asks for a discipline of imagination that resists drawing borders where gradients are more honest. It asks, finally, for a tolerance of silence, because the most telling facts here are quiet. A faint temperature difference, a slightly broadened line, a curve in a stream that would be straight in a different potential. He watches until the spiral becomes not an object, but a relationship among components he can name without possessing. He watches until the halo is no longer a puzzle, but a climate. He watches until the arms are not decorations, but transit lanes for material learning to become bright again. When he turns away, he does not exit its presence. He carries its grammar. He will use it to read other structures the same way, to look for places where breath becomes air, where memory becomes pattern, where exchange becomes identity. The mirror has done its quiet work. It has given a way of seeing that travels. In that way of seeing, the future does not flatten into despair at entropy, nor inflate into fantasy about escape from law. It becomes a patient acknowledgement that order can be coaxed for a long time if energy is introduced with care and released with respect. The Milky Way in the mirror is an essay about that practice, written in cold light and thin gas. It ends without a period. The reader supplies cadence by continuing to move. Night carries him farther until names fall away and only measures remain. In the window hangs a swirl of light that once was home and now is a sentence he can recite without speaking. The sentence says that structure is patience, that brightness is borrowed, that memory is a map with soft edges. It says that belonging does not require walls. It says that distance, properly held, is a kind of kindness that lets forms keep their dignity. The instruments quiet one by one, not from failure but from understanding. The microwave sea evens to a near-perfect hush. The compass it provides is gentler than any arrow and more reliable than any star. Along that hush, small differences guide like braille, written on the back of the universe. He traces them and knows where he is by how little needs to be corrected. This is what navigation becomes when the destination is comprehension. He lays a hand against the panel and feels only the faint murmur of heat leaving. Emptiness is busy with very small tasks. Electrons drift with laws that do not tire. Photons age gracefully into red. Gravity continues to hold conversations in second derivatives that no eye can see. The beauty of it lies in how unnecessary witnesses are, and in how generous the cosmos is to those who witness anyway. The spiral in the window grows smaller and more complete. Its unlit halo holds it like a memory holds a name. Its arms do not ask to be counted. They ask to be understood as paths where matter becomes music for a while. He has learned that the frontier is a gradient, that outside is a slow negotiation, that identity is the shape a conversation takes when given time. He sleeps, and the ship keeps the long promises it can keep. Somewhere ahead, another filament waits, not as a surprise, but as a continuation of a quiet pattern. The journey has no ribbon to cut. It has only this, a steadiness that turns scale into meaning, and meaning into a soft light that is enough. End of script. Sweet dreams.